And start recording. Okay. All right. And with that, we are good to go. All right. Welcome everybody to the Hyperledger AnonCreds workshop. Using ZKP verifiable credentials everywhere. We'd like, on behalf of Hyperledger, we'd like to thank the creators and organizers of the workshop, Stephen Curran, Rodolfo, Miranda, and Patrick Saint-Louis. We really appreciate all the hard work that went into this. Hyperledger, as some of you may know, is a global ecosystem for enterprise-grade blockchain technologies. We host the software projects and the communities that build things like Hyperledger AnonCreds, Indy, Aries, Fabric, Sawtooth, as well as projects, Bezu, as well as other projects like Cacti for blockchain interoperability, Bevel, and others. So we'd like to thank everyone for joining us. We are live streaming this. I'm going to post the link to the live stream if you want to share it with your colleagues. This meeting is being held under the Linux Foundation antitrust policy. If you have any questions about these matters, please contact your company counsel, or if you're a member of the Linux Foundation, feel free to contact Andrew Updegrove of the firm Gesmer Updegrove LLP, which provides legal counsel to the Linux Foundation. And this meeting is also under the Linux Foundation Hyperledger community standards. Everyone's welcome here, and as the chairperson of our technical oversight committee says, be excellent to each other. I am going to stop sharing and turn it over to Stephen, Rodo, and Patrick. You guys have it.
All right, welcome all. I am going to share screen and I'm going to start. There we go. Let me adjust a little bit more. Get things move to where they need to be. All right. Okay, welcome to the Hyperledger AnonCreds workshop. We've got a lot of things in to share with you, and so we'll get started pretty quickly. I think Sean's given us a good introduction, covered the question of who Andrew Updegrove is and whether he is actually just a chatbot, but you know, he could exist. The goals of this that we came up with as we started with this is listed here. You know, understanding verifiable credentials in general. So we'll do that quickly at the beginning because I think a lot of people here will know that. Go into the unique capabilities of AnonCreds and what makes them different from other verifiable credentials. We're going to use a thing called traction to experience using AnonCreds, and we set out some prep information, and prep information is available for those who want to join in and participate in that, or we'll just walk through it and you can see it. Hopefully understand a bit of the cryptography. I hope to do a time permitting. We're going to balance that, but a high school math session on what anonymous credentials are, what zero knowledge proofs are in particular, and how that works. See how they're used today in a variety of contexts, how they're used not just with historically as they've been used with Hyperledger Indy ledgers, but actually in a number of places. Some new capabilities available and sort of a future. And so we want you to come away with this to be able to say, how can you use AnonCreds in your app, build frameworks that use it, either open source ones that we also participate in, or proprietary ones that your organization builds and makes available to others. Use of AnonCreds in all sorts of other contexts, other ledgers, other VDRs as they're called, and we'll talk about what VDR means in a bit. For those that are into cryptography and actual deployments, contribute to AnonCreds, both the current version and the future version, and what we're going to talk about is the future version. So those are the goals. Just moving one thing around. So let's get into it. Part one is going to be more or less about AnonCreds. Part 2, we'll get into the cryptography zero-knowledge proof, ledger-agnostic AnonCreds, AnonCreds in the W3C verifiable data credential format, which is new and kind of interesting. We're going to see a demo of that with AnonCreds used with a W3C API known as CHAPI, and then talk about making credentials beautiful with the overlay captures architecture, and finally finish on AnonCreds V2 and what's coming in what we're working on in a working group here at Hyperledger. So with that, I'll get started with online identity with verifiable credentials. So a quick refresher or intro for anyone who's new to this. Verifiable data is necessary in huge numbers of business use cases. Business relies on being able to get trusted information shared between many parties. So you've got things like personal identification issued by the government, passports, birth certificates, driver's licenses, using those in a variety of locations, including when you're caught for speeding or other such nasty things that this police officer is so angry about. Other things like, travel, even, being certified to work, being an engineer, being a doctor, being a lawyer, and being able to prove that. And then this other one, certificate of incorporation. Organizations are people too. And so organizations need identity, and they need to share verifiable data. So that's the context we're talking about. The paper credential model has been around about 2,000 years. It works like this. Some issuer provides a piece of paper that has identifier information, identity information, some sort of information, and they give it to a holder. That's one transaction that occurs. The holder holds onto it. They might put it in their wallet. They might put it in a filing cabinet. They just might put it on their desk, but they keep it. Sometime later, the verifier, a verifier, and could be many, want to see that piece of paper because they want to do some interaction with the holder. So they ask for that piece of paper, and they take a look at that piece of paper, and they sort of judge, does this look like a forgery? Does it come from the place that they want it from? In theory, it proves who issued the credential. It's got some marking on it, who issued the credential. It has some binding to who's holding the credential. It might have a picture of the person on it. It might just have their name or their address, and some other mechanism is used to prove that, oh, that name is the same as this name of this person, and that the claims are unchanged, that it's not a forged piece of paper. And so mostly in that, the verifier knows who they want to have issued the credential, but they want to look at the person in the paper and sort of see, is this forged in any way? Trust comes from, mostly from, do they trust the holder? Does it really look like a legitimate document? But they also are making sure that they know who issued it, who issued that credential or that piece of paper. I'm going to underline here that there's two parts to this: credentials and protocols. Credentials, we don't really think of protocols when we talk about a paper credential model, but it really is included, which is somehow the issuer gets the piece of paper to the holder, and somewhere there is the holder gets the piece of paper to the verifier, and that's the protocols involved. There is a link to the slides. Yes, sorry, it is on some of the slides. Bit.ly AnonCreds slides.
And also, you can go to the wiki page on the links I just shared. I'll share them again in a minute, and the slides as well as the lab documents are all up there.
Yeah. I'll jump to that quick question that I had asked. AnonCreds is usable in the Hyperledger identity stack, Aries, Ursa, and Indy. That's where it started, but the extraction of AnonCreds into its own project allows it to be used in many other places. So that's partially what we're talking about and introducing today. Okay. When you present a paper credential, the verifier is making trust decisions. They're looking at the technology, the paper, words on it. Does it look forged? Does it look like a legitimate representation of the credential they asked for, the piece of paper they asked for? But they're also looking at governance. What is the source of the data? British Columbia in this case, for this driver's license, and do I trust British Columbia? That tends to be obvious when it's things like banks, Bank of Canada or the government of British Columbia, but there's tons of use cases where the paper comes from some other source, and you've got to decide, the verifier has to decide, do they trust the issuer? Do they trust the processes the issuers have? So paper credentials in the digital world, or just generally credentials in the digital world right today, are scanned and emailed. So that's the normal way to do it. So you take a picture of it. These are actual instructions from Google of how to send your ID to Google. You take a picture of yourself holding your driver's license. Looks like you cover some of the information and only show the photo. I don't know. And there you go. So this is obviously not a sustainable, useful approach. So this is where verifiable credentials come in. Basically, we have more or less the same actors, the issuer, the holder, and the verifier. We add this thing called a VDR, Verifiable Data Registry, that we'll talk about. And we go through the same two ceremonies, the same protocols that we saw before. The issuer issues it to the holder, and the holder presents it to verifiers as necessary when they want to. Who issued the credential is proven, so that there's, again, a tie to the issuer of the credential and the credential itself, and that's done through cryptography. The claims are unchanged, again, through cryptography, that there is, a signature, to use the term, a signature on the credential that the verifier can verify. Who holds the credential is sometimes proven, and we'll talk about that in terms of AnonCreds and other credential models, and that the claims have not been revoked. This is a new one that is added by the ability to use digital credentials, that you can check revocation of a credential in real time as a verifier. Remember, these are two transactions: issue to holder, and then the holder holds onto it. Holder to verifier sometime later, or as often as they want, as a separate transaction. Still required is, do you trust the issuer? Not necessarily required as a holder, because of these things that are built in. It's almost impossible for the holder to forge the credentials, so the holder is of less concern. Now the verifier's focus goes over, do you trust the issuer? So you got to know who the issuer is and whether you trust them. Credentials, presentations, and protocols are all involved. So in this case, the credential and the presentation may be different. So a credential comes to the holder. In some cases, the holder presents a derivation of the credential called a presentation to the verifier, and that's, so we add that to this. But protocols are completely involved. How the issuer gets the credential to the holder, how the holder gets it to the verifier, all of that is there. Okay, I do want to point out that VCs are different from OpenID Connect. So OpenID Connect is the login with Facebook model. You have the same parties. User in the OpenID Connect model is the holder in the VC model. The issuer is the same. The relying party is the verifier. But what happens here is there's a single transaction. The issuer is asked by the relying party to coordinate the conveyance of the data of the credential. The user asks the issuer, contacts the issuer, and the data is passed directly from the issuer to the relying party. This is all done in a single transaction, and the issuer is involved in every interaction. And that's one of the things we want to get past. We don't want the issuer to know when the user is interacting with any given relying party. And so you can think of that, obviously, in government terms. It's bad enough that Facebook is able to monitor all of the things you do, but government oversight of that, things like the government being able to see every time you buy cannabis or you buy alcohol or whatever interactions you're making, is not a good thing. You do need to show you are abiding by the laws. You're old enough to participate in things like that, but you don't want government oversight tracking all of those things. And so that's why the OpenID Connect model is not sufficient for this, and why for that and a number of reasons, scaling being a big one, but that we want to move to something different. The verifiable data registry, I talked about that through this. Where that comes in is what allows the presentation between the holder and the verifier to occur without involving the issuer. And basically what happens is the cryptographic material used to identify the issuer and sign the credential is put onto a registry. The issuer, when it issues the credential, issues them to the holder, to as many holders, 1 million holders, 1 billion holders, based on the key or keys that go onto the registry. And then when a holder presents data to the verifier, the verifier reads from the registry and uses the information they read, the public key that they read, to be able to verify the credential. And so that eliminates the issuer from being involved in the actual proof, the presentation transaction that occurs. So hopefully that all makes sense. I always like to underline this over and over. When a credential is issued, it goes from the issuer to the holder. No part of the credential goes on to the verifiable data registry. No transaction occurs when the issuer issues to the holder. The only thing that happens is that is done as part of a setup, as we will see, and then the issuer issues to the holder the credential. Wanted to talk briefly about verifiable credential ecosystems in 2023. Basically, there's coming down to 4 and perhaps a few others that are 4 major communities that are coming together on verifiable credentials, and these are starting to merge. These are sort of forming over various times. The initial 2 were primarily in this area, the W3C verifiable credential data model, the standard W3C verifiable credential model, signed using data integrity proof. So that's the verifiable credential type. The exchange protocols that you'll hear about are CHAPI and VCAPI in that community. Hyperledger, where you are today, has primarily focused for the last 6-7 years on AnonCreds with zero knowledge proof, as well as VCs with JSON LD. So again, the same credentials that are here. So Hyperledger, things like Aries, supports both of these things. The primary exchange protocols are called DIDCOM messaging, and then Aries data exchange protocol. So that's the protocol there. Relatively new in the VC field is OpenID Foundation, which has been using JOTs and selective disclosure JOTs. We're going to talk about that a little bit later, and possibly other formats. They're again, OpenID is attempting to be agnostic to the protocol type. The protocols they use are called OpenID for VCs. This is not the same as OpenID Connect. So they aren't using OpenID Connect, but they are using the foundations that underlie OpenID Connect for these. And then there's the ISO working group, and in particular, the mobile driver's license working group. They have a thing called MDL, which is literally a mobile driver's license, which is built on the concept of MDocs, which is the verifiable credential format. And they are developing various standards for how presentation primarily gets done, but also protocols around issuance and working on those. So those are the VC ecosystems that are happening. With that introduction to verifiable credentials, let's jump to what Hyperledger AnonCreds is. So the big thing that AnonCreds adds is zero knowledge proof technology, and this is exists in 4 enhancements over the basic verifiable credential model. The first one is selective disclosure, and this is one that is now appearing in all of the other communities, and the one that that you'll see more and more. This will become the absolute minimum that a verifiable credential format type will have to support. So this means that when I present something, I get a credential that has all of the data on it, but when I present it, I only want to present some of it. So in this case, I present that I have a credential that was issued by British Columbia, but I'm only going to show you my picture. So selective disclosure is absolutely crucial for minimizing how much data you're sharing and increasing the privacy. Because the data is now cryptographically signed and the verifier can do more with it, they need less data. They just need the minimum data for the actual transaction, not data to collect for other purposes. So that's selective disclosure. Second one are called predicate proofs. This is only in AnonCreds from the major types. And a predicate proof basically says I can prove something based on data in my credential, but without disclosing that credential or without disclosing that attribute. So in this case, I'm walking into a bar. I present my credential. I show that it came from British Columbia, and I show that I am old enough based on my date of birth to purchase alcohol, but I don't actually give you my date of birth. And again, this is a data minimization approach. It allows you to do not share more than is necessary for the transaction needed. So those are called predicates. Predicates have limited usage. They have to be based on numbers and things like that. So we'll get into a bit on that as we talk more about AnonCreds. Predicate proofs. Third one is derived presentations with unlinkable identifiers. That's a handful, but what that means is basically when I present this credential to a verifier, there's no, in the presentation, the wrapper of the presentation, there is no unique identifier for either the credential or the person presenting. There may be a and if the verifier asks again for the same data, they get a completely different credential. Now, the business transaction may require that a unique identifier be given in the attributes that are shared. So, for example, I may have to, as a result of the transaction, share my name, but that's not required by the presentation process. So where it's possible to use essentially anonymous presentation, that can be done. So no correlatable identifiers is another word for unlinkable identifiers. Unlinkable is becoming the common term used in the VC community. That also means that when one verifier gets some data, they can't correlate it with another verifier, either previous credentials they also receive or other ones received by others, so they can't correlate behind your back. And finally, multi-credential presentations. With the AnonCreds, you can present multiple credentials at the same time and show that they were all issued to the same holder, to the same what's called linked secret, and we'll talk about that a little later. But there's a proof that all of the credentials were issued to the same holder, the same wallet, if you will. So those are the unique capabilities of AnonCreds that we're going to get into. What is AnonCreds? It's a project at the Hyperledger Foundation. As mentioned, it is the same technology that was previously in the Indy project and then extracted out and moved into into its own Hyperledger project. It consists of a specification, a v1.0 specification of the AnonCreds, sort of mixture of data models and protocols, and a working group to evolve that. There is a full open source implementation in Rust of the AnonCreds specification. It's basically the give or take fourth implementation of AnonCreds, derived from Hyperledger and Indy and a thing called ID Mix from IBM that had been around for a number of years, heavily used for the past 7 years in the Hyperledger's self-sovereign identity stack. So that's the Indy Aries Ursa stack that we've talked about, or that was mentioned in chat already. The new implementation is verifiable data registry agnostic. This is the new thing that we wanted to accomplish in doing the specification, which is previously it was very tightly tied to use of Indy and Hyperledger Indy ledgers. It now, as we'll show later in the presentation or in the workshop, that it can be used with a variety of data registries. And then finally, there's a working group defining AnonCreds v 2.0. So that's the next generation, and we'll talk about what that means. Basically, it means that we want to retain or expand on the capabilities. And so it's the capabilities of AnonCreds, those things that I mentioned on the previous slide that matter, and not so, and in doing that, we will adjust and modernize, for example, the underlying crypto signatures that can be used and things like that. The important thing is not so much the precise details of what is implemented today, but rather the capabilities and making sure that we're retaining those capabilities, those privacy preserving features that make AnonCreds so important. These are the things that I talked about mostly. All of the cryptographic features of any verifiable credentials format. So per the W3C, and we'll talk about this a bit, the only thing that a verifiable credential, the two things that a W3C verifiable credential tells you is there is tamper evident issuer attestations about a subject. So you've got a subject in there, and you've got an issuer involved, and you can detect if you know who the issuer is, and you can detect if there's been tampering, forgery done on the credential. That's all. So things like who it was issued to, revocation, other things like that are sort of outside of the W3C spec, and it's sort of left to others around the W3C spec to use that. AnonCreds is actually opinionated on that and includes these features that I've talked about in the previous slides. I would add this no correlatable identifier is very helpful for governments because it means that there is no new identifier introduced for people. And for those who have experience in government, adding new identifiers and the rules around using it. If you think about in the US, the SSN or the SIN in Canada, or national identifiers, there's all sorts of legislation rules and so on about how to use that identifier and how it can be shared. Without introducing any identifiers, correlatable identifiers, we avoid that problem. I would add no other popular verifiable credential technologies offers all of these capabilities, and in particular, the only one they do offer, and we're delighted to see it, is selective disclosure. The rest of these are AnonCreds only features, if you will. I'm going to talk about a lot of these things over the course of the workshop, or we are. Overall basis is of AnonCreds v1 is CL signatures, so there's a link here to that. An RSA-based cryptographic suite. Canonicalization describes how you convert a credential, a bunch of JSON that is a credential, into a signed object that can be presented. That's known as canonicalization. It's very simple in AnonCreds. Basically, signatures are applied to 32-byte integers. So basically every piece of data, every attribute in a credential gets converted into an integer and signed. And basically the rules are, if it's an integer in the data, in the raw data, it remains at that. If it's not, it gets stringified and converted into a hash, which is an integer. So if you've got a picture, if you've got a date in text format, those types of things, those get converted into hashes basically and get signed. Integers remain integers, throughout, and that is why predicates work only on integers. They don't work on, for example, string values. Predicate use a thing called bullet proofs, which I will leave to others to figure out and understand. Selective disclosure, no correlatable identifiers, is based on a thing called blinded signatures. They've been around for, I believe, late 70s, I think, when the first idea of that came about, but commonly used. The linked secret, which we're going to talk about, is a Pedersen commitment. So again, link in there to what that might be, and you can understand it, but we'll also talk a bit about how that happens. And finally, revocation is based on a proof of non-revocation. You're actually proving your credential has not been revoked, and we'll talk a little about that in the course. So now we get into the meat of what AnonCreds is and how to use it. And that's where we're going to get into some demonstrations and presentations. Answer to Dave's question, could AnonCreds be used on Ethereum-based ledgers? Yes. And that's the idea. We're going for a ledger-agnostic AnonCreds, which is you can still use AnonCreds as defined in the specification, exchange them with others, but resolve the objects, resolve the data you need onto other ledgers, including, I think Ethereum would be a great use case. I don't think it's been done yet. It has been done to Fabric, Cardano, checked, databases, did web, all sorts of them, and you're going to see a bunch of those today. So what happens? There's basically 4 parts to using AnonCreds. Setup, which is where data gets published from the issuer to the verifiable data registry. Publishes the public information they want everyone to be able to get to be able to see it. Commonly, we use the term, we say, oh, it gets published to the ledger, but the correct term is verifiable data registry. So you'll see me cross that out and put in VDR there, because it can be a lot of things. It does not have to be a ledger. The holder creates a linked secret. We'll talk about that in the setup section. During issuance, there's a back and forth between the issuer and the holder. There's actually 3 steps: an offer from the issuer to the holder, a request from the holder to the issuer, and then the issuer creates and signs the credential and passes it to the holder. Presentation, this can, once a holder has the credential in their wallet, in their secure storage facility, whatever that might be, the holder may present it to any number of verifiers through any number, through transactions with each verifier. During that, it's a 2-step process. The verifier requests a presentation from the holder constructs a presentation with revocation if necessary, with proving my credential has not been revocated if necessary, and provides that to the verifier. And then the verifier verifies the presentation by pulling the public data that the issuer published during setup and uses that to verify what the holder provided. And finally, there's revocation, and that sort of happens in a couple of ways, and we'll talk about that. But basically, when necessary, the issuer publishes a list of credentials that are being revoked in a way that's not correlatable to the holder. And the holder uses that to prove as part of the presentation that, that their credential has not been revoked. And the verifier, again, can use the information to do that. So, AnonCreds, data and processes. So this is the next set of things we're going to talk about in the presentation. So we're going to go through the setup of the setup step. We'll go through the issuance step, and we'll go through the presentation step. Okay, so publishing objects involves the issuer writing things to the verifiable data registry. So holder's not involved, verifier's not involved, no verifiable credentials, no proofs. we're just writing some things, including public keys, to the verifiable data registry that we want everyone in the world to see. No private data at all. That's got to be super clear. No private data. It involves two objects we're publishing. A schema object. So the schema object is a list of attributes, and I've got an example, and I'll jump over to it. Hopefully that'll work. Okay, good. So this is I'm looking at a Ledger browser on the sovereign mainnet, and here I just randomly found a link to a transaction that is a schema for a credential, and those are the list of attributes in this schema. That's all you know about them. So that just this list of names, and these list of names are totally set by the publisher of the schema. There's also two other things: the name of the schema and the version of the schema. So that's all of the information that goes into the schema object. It's technically not needed for the cryptography to work. So what you'll see is the next object, called the credential definition, that gets created actually is based on a schema object and imports into that object all of the attributes, the list of attributes, and the reference to the schema object. So for the cryptography, for the actual signatures, it's not actually needed, but it's more for governance. It allows the sharing of common schema, and the idea is to minimize the different schemas being used in the world. Basically, to make the life of the life of verifiers easier. We want to have the verifier able to accept a credential, say, from any university, and it be in the same format. Almost no prescribed metadata in the schema. So for example, in the W3C VC data model, you must have the issuance date as a field in it, but there's no prescribed metadata in a AnonCreds schema object. In 2.0, we may adjust that, we may make changes, but in 1.0, so there's no prescribed attributes. Right now, and implementation so far, it is a simple list. There's no complex JSON, not even nested data structures and so on. Nested data structures could be supported by flattening the data structure. So that is possible. It's not been done, but certainly would be possible. However, dynamic arrays cannot be supported, and so that is something to understand. So the requirement is that the number of attributes in a credential is defined at setup time, so that every credential has exactly the same number of attributes in it, and that results in you cannot support dynamic arrays. If you do need to support dynamic arrays, there is a way to do it, which is you basically stringify the JSON array, you convert it into a single element, and use a data URL for the data in each credential. So those that need to worry about this, the key thing is you can't have dynamic arrays in a AnonCreds schema objects, but there is a way to pass such data if that's totally necessary. And if you need it, ask the AnonCreds community and you'll get help on that. So that's one object that has been published. The issuer has said, this is what my schema is going to look like. And they may, the next thing is they create a credential definition. This is done by the issuer. The credential definition inhales the attributes from the schema. As mentioned, it could be the issuer that publishes the schema object, or it could be someone else entirely, and the issuer is simply creating their credential definition based on somebody else's schema. And that would be a good thing, because it shows that people are sharing schemas and reducing the effort of verifiers. So, list of attributes. Let's go to a quick example. Again, this is that same This is based on that same schema. So it's got a reference to the same fields. It's got a reference to the same name, the same schema version. And the actual data is some cryptographic data. And you know that because you've got all these really long numbers. This is the actual public information that the verifier will need to pull in to be able to verify the credentials. So they will actually pull this credential definition in when they receive a presentation. They will use this data in here, data associated with each element, and cryptographic, specific cryptographic values, pass that into an AnonCreds algorithm, and they will get back a verified, not verified answer. So this is the actual meat of what will be used to verify a credential. For those with eagle eyes, you'll notice that these fields are mostly the same, but there's an extra one in here that we're going to talk about in a moment called master secret. Everywhere else, it's called link secret because we wanted to get rid of that, but it has not been eliminated yet in the actual published data structure. But the link secret is added to the credentials. It is the only extra thing that's in here as far as the list of attributes that are in a credential. This example actually had revocation supported. So this is some information related to proving revocation. So there's some extra data on there. So there's keys, public keys involved for the issuer and involved as well for revocation. With a published credential definitions, millions of credentials can be issued. Again, nothing goes on the ledger at issue time. Hope that's clear. So no credentials are stored in the VDR, no credentials. This is what gets stored in the VDR, the schema and the credential definition, and also revocation information. But no information about the credential itself goes on the VDR. Okay, setup, the last step is the holder creates a link secret, which is going to lead to our digression. The link secret identifies the holder and it is put into all credentials they receive. And so this is how, well, we'll get to this. The link secret is simply a unique identifier, a UUID, so a very long unique identifier. It is handled as a blinded identifier, and this is what allows us to have no correlatable identifier. So we have an identifier, but we're blinding it, which is a cryptographic term that makes it so that it is not presented to the verifier as the identifier itself, but rather it's blinded. But the holder can prove that they know what the identifier is, that they uniquely hold the knowledge to know what that link secret is. And so that's how this occurs. So it is unlinkable both for issuers and holders. So there's no linkable identifier shared with issuers, no linkable identifier shared with that should say verifiers. Got to fix that with verifiers. So now I'm going to get into the holder binding issue and briefly go into that. So the verifiable credential holder binding issue is the following. So this is a bit of a digression. We're talking about setup. We're talking about the thing called the link secret, and it is this piece of data that is known by the that is put into the credential from the holder to the issuer, and then put into the credential and used to identify who the holder is. So holder binding issues, some basics. Excuse me. When verifiers receive presentations, they want to know the relationship, often want to know the relationship between the holder and the credential they are presenting. So if you have a driver's license and you're presenting a driver's license, it's obvious to everyone that the verifier is expecting that the subject of the driver's license is the one presenting it. And so there needs to be some way to bind the credential being presented with the person or the entity that is presenting it. In W3C terms, they talk about a subject. The credential is about a subject. The credential is held by a holder. So what is the relationship between the subject and the holder? That's known frequently as the holder binding issue. I talked about it earlier, is you want to prove that the credential was issued to the holder. So one of the things that AnonCreds does is it's very deliberate to say that a credential is issued to a holder and only that holder can present it. In the W3C VC data model, holder binding is currently out of scope. The issuer makes tamper evident attestations about the subject, and that's it. So we know who the issuer is. We know that the attestations have not been tampered with when they're presented. We know the subject identifier, but we don't know the relationship between the holder, the subject, and the credential. And that's the bigger issue. This is a picture, figure 10 from the W3C verifiable credential data model. And it basically shows this, that an issuer issues to holders. Holders can transfer amongst holders, and any or all of them can present a credential. And so in the data model itself, it's not to say that in practice, not to say that it's impossible. I'm just saying in the data model itself, there is no binding between the holder presenting the credential and the credential that they're presenting. Anyone, and basically anyone can present any verifiable credential. It's up to the verifier to do that binding, to do that extra verification if it's needed. There are cases where holder binding is not even needed, just possession of a credential is good enough. Money is an example of that. If you present money, you don't need any binding to you, you just need to present money. So it's proof of possession is all you need to show in presenting it. Not that you want to use verifiable credentials for money, so don't let me add that. So there are other techniques, and this is commonly what's done in other, in, for example, OpenID for VCs. The idea is the holder has a DID, which contains a public key. They on issuance, the holder provides that DID and proof that they control that DID to the issuer. And when the issuer verifies that signature and inserts that DID into the credential. So they basically request proof of control of some identifier, and then they use that. And then on presentation, the holder adds a proof that they control the subject ID DID that is in the credential. And that way the holder proves that they control the DID. It is in the DID signed by the issuer, and on presentation, they prove binding to that. There are other ways that it could be done as well. Some mechanism that the issuer creates, some, you might call back to the issuer to prove it. You might have to present another piece of ID. So this was commonly done with the COVID credentials, which is you would present your COVID credential that would get verified. It would show what your name is and show your ID, your paper ID, as a way to prove that you are the subject as the identifier, as identified in the credential. The VC could include a picture of the subject. It gets presented, and then that can be compared on an in-person event. So that's another approach to doing that. But there's got to be, in often, again, I underline often, and again, I think it's a very, very high percent of cases. Often, the verifier does need to know the holder's relationship, their binding to the credential they're presenting. So that's the general issue of holder binding. And AnonCreds takes a very opinionated approach to that. It provides a thing called a link secret, and that formally defines exactly how holder binding works in AnonCreds. So unlike W3C credentials, the data model, where there is no formally defined way to do holder binding, all AnonCreds are issued to the holder's link secret, and only a holder that knows that link secret can present the VC. A holder link secret for all credentials they receive. In theory, they could have multiple link secrets, but whenever they create, wherever they present credentials, multiple credentials together, they must use the same link secret. So if you get a credential from 2 different link secrets and try to present them together, it will be rejected. So there's a verification that any credentials presented together will be must have used the same link secret. If you go through and think about how the link secret works, it is pretty much exactly the same as what we talk about here, but instead of it being a DID with a public key associated and you prove a signature on issuance and presentation, basically you blind the the link secret from the issuer, and then you present proof from the holder to the issuer that you know what the link secret is without sharing the link secret. Classic zero knowledge proof. You prove that you know the link secret without sharing the link secret itself. And then the issuer inserts the blinded identifier into the credential. When the ZKP, when the holders present that presentation based on that credential, they do the same thing. The presentation includes proof the same link secret was used for all the source VCs, and that the holder knows the link secret without sharing the link secret. Again, zero knowledge proof. So hopefully that makes sense about holder binding, the importance of it, and B, how AnonCreds handles it in an opinionated way, which is somewhat different from other credential methods. This accomplishes exactly the same thing as the link secret does, except that it shares a correlatable identifier, a linkable identifier. Every verifier that receives a proof, a presentation from this credential, gets the same DID and gets the same proof, and that is correlatable data. Okay. So, lab 1. Now we're going to take a break from slides, and we're going to go into lab 1 and sort of walk through that. We're going to use traction, as I mentioned. Hopefully those that are joining did some sort of preparation. So all of the links in here are https bit.ly/AnonCreds. There's a prep one, there's a labs one, and then the other labs are like that. So in this, we're doing the setup step that we just covered. Define a schema, and you're welcome to define multiple. Publish the schema, and then publish the definition, the credential definition for that schema that you create. So that's what we're going to do now. I'm going to do this, so those who didn't do the prep or anything can just follow along, but I'm going to walk through the steps. Hopefully, I don't often use a wallet on my device, but hopefully that's there. So I am, yeah, good. So this is the traction product. So traction, we didn't want to bury people down in using a CLI, a command line interface for doing this, or spinning up their own Indy or Aries agent or anything like that. So this traction is a multi-tenant instance of an Aries agent that provides a user interface and an API for managing multiple agents within a single instance. So everyone is using the same instance of Traction to this URL. And then everyone has a tenant, and everyone that's done the setup has a tenant within it. And that gives them this interface that allows them to do a bunch of things related to issuing, setting up, issuing, and verifying presentations. So that's what we're going to use for this. Over here, I have my wallet. I have my machine, or my smartphone, and I've got the BC wallet. I've got Orbit wallet installed as well. And so I'm going to go through and do this. Now, in this case, I don't need the wallet because we're not going to get involved in that because we're just doing setup right now. So I don't know why I just activated that, but I did. Okay. So the way we do this is, so we have a setup. By the way, I have connections created. So I've got my BC wallet connection and my Orbit connection. And I'm going to do a configuration. I'm going to set up a new schema. And so there's instructions in the lab what to do. I recommend following along for the first one using exactly what we provide because it makes doing the presentation easier, but feel free to make whatever schemas you want and however you want to do it. So I'm going to do a schema name called student ID. I'm going to use 106 because I can't remember how many times I've tried it in the past just to make sure. And I'm going to use a handful of fields. I'm just going to create 4 fields. So I'm going to have a given names, family name, click the plus. I'm going to add a date of birth, which is going to be what's called a date int, and I'll get into that. And I'm going to have an expiry. So date int is, if you recall, I said that if I'm going to use predicates, and date of birth and expiry are things that I definitely want to use predicates on, they need to be integers. So date int implies that the date of birth I'm going to put in is not an ISO string, but rather it's an integer of the form year, month, day. And this is talked about in there. So when we present, I'll be showing the format of that. Expiry is the same sort of thing. So I'm going to create that schema. And that schema is out there, 106. So I can look at the details of that. So I expand down here and view the raw content, and I can see when it was created, the schema ID. This is the DID of the issuer, me. Here I've got my student ID, name, and the version. Again, I've got the same sort of information in here. This is the actual schema on the ledger, and there's my list of 4 attribute names. And then I can also see this, that I have a sequence number, which is the transaction that occurred. Now, this was written to a thing called bSovereign test, which is a ledger that a sandbox toy ledger that BC operates. So Traction was developed by the government, a team at the government of British Columbia. I didn't mention that. So and they are operating this instance of Traction, and then they also operate the Hyperledger Indy network to which these objects are being written, and we can look at those. Those are available. So I've now created that. The thing I need to do now is, so that's step 1. I've created the object, I've published it. Step 2 is to create the credential definition. That's kind of funky. But I'll click on that to create the credential definition. Here, I'm going to use the student ID schema. So it's referencing the particular schema. And here I'm going to call it U of Stephen 3, because I think I've used 1 and 2 just to be sure. I'm not going to invoke add revocation, but this is how you would do it. Add revocation, you would also be asked the number of credentials. We'll talk about that per revocation registry. We'll talk about that in the revocation section. So for now, we'll create it without revocation, and we'll hit create. This is actually the most intense part of the definition. We're generating a bunch of large data. So that credential definition has been created by the AnonCreds library, and now it is being published to, in this case, an Indy network. And if I look over here now, I have it published on it, and I've got a link and an identifier for it. So I've published my credential definition. I can actually look over here and see I've got that credential definition. I created it at 9 o'clock today. So that's it. We now have those things. Oh, I was going to take a look at the raw data. Not much to see here. We'll see more of this later in the definition. This is not the actual credential definition. It was more like what I showed earlier. This is just the traction information recorded to find where it is. Sean, can you put in that AnonCreds, the bit.ly address for the slides? It's bit.ly/AnonCreds slides with the S in capitals. Okay, that's it for this. That's all we're going to do for now. That is what it takes to prepare to issue a verifiable credential. There's a bunch of stuff going on here. The biggest thing here is you need an interface to whatever VDR you're using. And you've seen now an example of using Indy for that. Later on, Rodolfo is going to present using Cardano. After that, Patrick is going to show using did web, so using just a web server to do that. So there's all sorts of places that these objects can go, but we've basically published 2 objects to this. One is the schema itself, which is just the simple list of attributes, the name and the version, and then this credential definition. And with that, we've wrapped up this section of it. I will leave, say, 2 minutes for any questions that we might want to go over, and let people run the lab themselves, walk through those simple steps, and ideally create a second one, a second schema, so that when you comes time to do a presentation request, you can build your own that has multiple credentials involved. Any questions that we should talk about now? I've been seeing the chat, hopefully following up, and thank you for all that are both adding and answering the questions. Thank you, Sean, for that. That's the slides link.
Yeah, I was having an issue with not capitalizing creds. And yeah, thank you again to everybody who's in the chat asking questions, but also for the great folks who've been answering them. Wade, Daryl, Patrick, everyone who's been pitching in, we really appreciate it.
Okay, Ed, in answer to your question, I think the decision to separate credential and schema was this idea that a schema can be shared. And the idea is you want communities to coalesce around a particular schema, and then all of them issue the same schema. They would have their own data. They would use the schema in the way they found needed, but they would use a common one to make it easier for verifying credentials that come from all of the issuers in a community. So, for example, in Canada, we did a lot of work. It's actually Dave Bigsby's on this call. I've seen him comment. Did a ton of work with the folks from Quebec and Ontario and some people there that came up with a common person schema with the idea that it would be used across Canada. All of the provinces would issue a person credential, and then and so there's a set of rules on what's, there's the fields that are in the common schema, and there's the values, and then each issuer can have separate rules on exactly how they would use it. Okay, so hopefully that's there. Asking for trouble there, Wade. Okay, I'm going to move on to the next section. So A couple of notes. Generally, and cred defs must be on the same VDR as the schema. It's not really enforced in AnonCreds. It is enforced more by the ledger or the VDR. It is required at least for Hyperledger Indy. And the reason for that is Indy does some verification of the object before it writes it. So it wants to know that you're doing a valid credential definition and you're using a valid schema. And so that's why it's done. Other VDRs may take a different approach and may not require that. And there's potential across the way that we could have a schema written on one ledger and credential definitions in other ledgers be used. There's not a particularly technical reason from a verifier or a holder from a client perspective, but it is sometimes required by the ledger itself. A schema must have an associated publisher ID, which is usually a DID. Certainly on Indy, it's a DID. And that is usually checked. So again, the permissioned writing rules of Indy requires that the publisher be allowed to write to the ledger. And so there has to be a DID associated with the schema. There must also be an ID associated with the credential definition. And this is how you know who the issuer is, the ID associated with the credential definition used for the credential. So again, that is often a DID. Doesn't have to be, but is often a DID. Must be a unique identifier for that credential issuer. And this is a lot, that subtlety that I've got in there of often a DID and things like that. The AnonCreds spec hasn't a way to enforce that. So it's just following along with what you're providing it, but the communities, the ecosystems around it enforce rules like that. So reminder, we've got our process here. We've now completed the setup. Our issuer has written all of the information to the verifiable data registry to enable the next two steps of the process. So good on us. Let's get into issuing. So we're back into a new one. Now we've got a new thing we're going to do. We're going to take the issuer and the holder are going to interact to issue a verifiable credential from the issuer to the holder. So we're actually going to construct some data, use that credential definition that's on the ledger to, or use the private data associated with that the issuer holds, the secrets that the issuer holds to provide the holder with a verifiable credential. So it is actually a three-step process in AnonCreds, which is slightly different from things like OpenID for VCs, it's a two-step process. Here it is a three-step process. So for those that are jumping into we are going to be having parts of the community that develop OpenID for VCs using AnonCreds. That will be an interesting component of it, is getting that three-step process. So the three-step process is called an offer. It goes from the issuer to the holder, and it says, here's the type of credential I'm going to issue. Here's a key correctness proof on that, and here's a nonce, a thing to prevent a replay attack for the issuer, and that can be used for non-correlatability. So an offer provides some cryptographic material from the issuer to the holder to say, here's what I'm going to present for you. Then the holder does a request to the issuer. This is where the blinded link secret is passed and the key correctness proof about the link secret is passed, so that the whole issuer knows that the holder knows the link secret, that the blinded link secret was derived from the link secret, but the holder doesn't tell the link secret to the issuer. They keep it secret. No one ever knows the link secret is. The holder needs to keep that secret. They also provide some entropy for the credential, some randomness for the credential. And finally, there's the actual issue step. The issuer to the holder, the verifiable credential that has been signed, constructed and signed, and is given to the holder. Protocol. So obviously there's a three-step process, and AnonCreds itself defines how to generate an offer, how to process a request, or to generate and process a request, and how to issue the credential. So the AnonCreds code simply executes these steps when asked, given the proper inputs. There has to be a way for the various inputs to be passed between the issuer and the holder to the issuer, and the issuer to the holder. That's the protocol step of this. Aries uses a specific issue credential protocol, which encapsulates all of these steps. It is, in fact, a general purpose protocol. It can be used for AnonCreds, but it also can be used for any other format of credential. It has been used for W3C credentials, for BBS Plus credentials. It can be used for any format of credentials. We are looking forward to, we've got a thing on the roadmap to try it with MDocs and see about getting that. A DIDCOM, so it is built on top of DIDCOM, so it's using a messaging protocol called DIDCOM. Hopefully, many are aware of that, but again, that's not the focus of this workshop, so we won't go deeply into that. But DIDCOM basically allows two parties to send messages back to each other, back and forth. So similar to Signal or Telegram, it is a messaging protocol. It is a DID-based messaging protocol, hence the name DIDCOM, and it provides end-to-end encryption. It does not have any central server involved in processing, looking at, and forwarding messages. There may be a need for intermediaries to pass messages along, but it's not inherent in the DIDCOM protocol, and all of the messages are end-to-end encrypted. The RFC 453 has some additions to it that go beyond the three-step process for AnonCreds. There can be a proposal that allows the holder to initiate the process. So the holder sends a proposal, which is followed by an offer, request, and issue. Also allows for negotiation. The issuer sends the holder an offer, and the holder says, that's interesting, but I'd rather you issued me this. And so it sends back to the issuer a proposal, and then the holder goes forward with that. And then the offer also includes other things. So the offer may include the actual data that will be issued. So if prior to issuance, the issuer wants the holder to see the data, they can pass that in the offer. And that's not needed by AnonCreds, but it's useful. It's part of the user experience in doing that. This is what a verifiable credential, AnonCreds credential looks like. So good to have JSON to look at, but you've got a schema ID, a cred def ID. You may have revocation information. In this case, it's all null, but you've got revocation information above and below. These are the actual values. So this is a credential with a single data attribute. It's got Alice Jones and encoded. And then there's signature data, cryptographic data in these two places. So that's what a credential looks like. I'm going to show you a transition of this information into a W3C formatted later. So we're actually going to take this data model and convert it to match exactly the W3C data model. But this is what was defined 7-8 years ago in the AnonCreds, initial AnonCreds work of what a credential would look like in the AnonCreds data model. So that's added for interest. Notice we had raw and encoded values here. Recall that I said that the raw values are the actual attributes. So that's what's being shared. Alice Jones is what the end user cares about, what they want to see. The encoded values are canonicalized attribute values as integers. So remember what I said, that what actually gets signed in a verifiable, in an AnonCreds credential is encoded, is the encoded value, is a number. And so what we've got to do is represent the raw value as a number, and that's what gets signed. So Alice Jones never gets signed. It's the encoded value that gets signed. The rules are dead simple. If it's an unsigned integer or an integer string, it's left as is. So if it's a number, it's left as is. Everything else is stringified and SHA-256 hash into an integer. So this is Alice Jones converted into an integer. That's why only integers, this is why only integers could be used as predicates. Hashes are not sortable. Predicates are, logical expression, greater than, less than. You can't do that with a hash. It's not sortable. So therefore, anything that's not an integer cannot be used as a predicate. Currently, both raw and encoded values are included in the credentials and presentations. What if the issuer uses, so that causes problems. It wasn't an ideal choice by the original designers. It allowed the issuer to define the canonicalization method they used, so they could use other rules here, and that's not ideal because the verifiers have to know what rules they're following to be able to use the credential. And the verifier must check that the encoded values are properly encoded. So this actually is an issue that the holder could exploit. A holder could put Dave Jones in here, and if the verifier doesn't check that the encoding has been done properly, they might see that the signature is correct on the encoded value, but might not notice that the raw value is different from what was encoded. So there is a verification that the encoding is done properly. In a future version, we will eliminate the encoded values as part of the credential or presentation, and so that those get generated on the fly according to very strict canonicalization rules, and that will eliminate these sorts of issues. So, little sideline there. That's it. That's issuing. Again, we've got another lab. Again, it's going to be very simple to do. Lab is followed in here. This time I am going to use my wallet, so I guess I better activate that. Oops. And let me get back to seeing my wallet and seeing my traction. So I've got my instance of traction. I'm going to go to the issuance, and I'm going to offer a credential. So the offer credential in this case is I have a connection. So actually, let me jump back to that. So I've established connections previously to my BC wallet and to my Orbit wallet. I could use either of them. Orbit is from Northern Block. There's a link in there as how to get it. So I've got a connection previously. I established that by creating an invitation, giving an alias to it, and then generating a QR code that can be used to connect to it. So that established a connection between the wallet and traction. So I now have a relationship. I've used DIDCOM to establish a relationship between this enterprise application and a particular wallet, my particular wallet. So I've got that connection. I'm now going to do an issuance. So I'm going to offer a credential. I'm going to use my U of Stephen. I'm going to send it to the BC wallet. Here, I can enter values in here, but I can use this to show the data. So I'm going to put an expiry date int. Now, a date int looks like this. 2026-10-01. So it is a date in YYY MMDD format. I think I said 4 Ys, should be. And I'm saying that this credential expires in October 1st of 2026. So sometime in the future. My date of birth, as everyone knows, is in 2001. So again, I'm using this format. I'm a young university student. I'm going to put in my name and my family name. Now, obviously, this is not how you would normally issue credentials. So Traction or any other application, enterprise application you use has an API that allows you to interface with backend systems that contain the information you want convey. So you establish a connection, you do some verification of who the person is, and then you issue a credential. And that's going to be done through some program that uses an API to send out this data. It's not gonna, you're not gonna type it in yourself, but you can. So I'm now going to look at that. So my data values are entered. They look like that. I can adjust them if needed, and then I'm going to send the offer. I'm going to jump over, and I've got a new credential in my wallet. So I've been offered a credential. I go in. This is the user interface that's available if you want. This credential up here is kind of ugly. We're going to show about later how to make that prettier and make it more useful. Also, look, these fields are pretty ugly. DOB, capitalized, date int, not nice, but we're going to show a way to make that much better. But we'll get to that later. But the data is what I suggested I would be offering. I keep wanting to use the mouse to move that, but I've got to do this on screen. So I have the option of accepting or declining. So I accept, and now I've got my credential in my wallet. So there's my list of credentials. I can look at it. I can scroll down. I can show all of the data for it. I can see who issued it. Not the most friendly name again. So again, these are the types of things that can be cleaned up. So now I've got my credential, and that is issuing. So what happened, as I mentioned, was there was a back and forth. The offer went, that triggered the pop-up and the decision to be made in the wallet of what I want to do with it. Once I said accept, it fired over the request for the credential. Traction, this Traction instance, signed the credential, prepared and signed the credential using the private key associated with the credential definition. So they used the private information to sign it. They fired it over, and that credential is now sitting in my wallet. And that's it. So again, we'll take a little break and let people carry out that lab and look for questions or comment, anything that I can respond to. So yes, you can't have slashes, you can't have those things, but we can make that look good. But it has to be an integer, a literal integer. So think of where the commas would go on that, and you can see how it is there. Revocation and things like that. Good. We're getting into good questions, but I'll leave those on the call, the folks that are helping on the call to deal with that. There's lots of good stuff there. Okay, that's issuing. Yes, DIDCOM v2. There's a lot of work in DIDCOM v2 going on. Maybe someone on the call can answer that, that knows more detail of the DIDCOM v2, but I think there is. Yes, the issue protocol in this demo was with auto accept. Yes. So how many DBs and networks are you using for this? So everyone is sharing the same instance of Traction. Whoops, that's not going to do it. So this, everyone that's running this is using the a single instance of, it's running Aries Cloud Agent Python underneath, and this Traction UI and API on top. And then we're using a single ledger, the vSovereign ledger. Thank you, Rodolfo. Okay. All right, we've got 2 more brief parts to go, and then we'll have a break. I'd like to get going on that. So we've done issuing. So now we've taken care of writing. We've taken care of issuing. We have a verifiable credential. As noted, when we did that, it was strictly an issuer to holder interaction. There was nothing written to the ledger as a result of issuing that credential. And that is definitely what we want. We want no data associated with holders to go on the verifiable data registry. We only want public information, non-correlatable public information that you want everyone to see to be able to do it. There is correlatable data about the issuer, and that gets into some interesting things like, what if this issuer is a person? That does get into the potential of how you would do that and where you would want to do that. That would give correlatable identifier if this issuer is a person. Or sorry, it gives correlatable identifier regardless of who the issuer is, but the issuer wants that because they want verifiers to be able to read that data. Okay. So now we get into the next step of presentation. Again, fairly straightforward. Now we've eliminated the issuer from the picture, don't care. We've got the holder prover, and we've got the verifier involved in this. The verifier is going to read off the verifiable data registry in order to verify the credential, but they are not going to contact the issuer. They may trust the issuer, but they're not going to contact or have any interaction with the issuer. So this is again where a protocol gets involved. So the issuer sends the verifier sends a presentation request, and the holder sends a presentation. So the verifier to the holder is, this is what I need from your request. I need a certain, we're conducting a business transaction and I need some data from you. And this is the data I need. It might be one credential, it might be data from one credential, it might be data from multiple credentials. It just is some sort of, we want to convey from the verifier to the holder what data is needed. Ideally, the verifier is respecting privacy and requesting only the absolute minimum they need. And again, because they're receiving verifiable data, they're motivated not to collect toxic private data. They don't want to collect any more than they need to. In this back and forth that I show here, the red are sort of outside the realm of AnonCreds. The black pieces are inside the AnonCreds elements, and the red are outside, which means, you know, let me keep going through that and I'll get to that. I think I jumped ahead a bit. So the request response model, verifier asks what they need, holder constructs a presentation based on what credentials they have, and the cryptography is verified. Looks like I screwed up in adjusting this and you can't see all the words. I'll fix that. But the holder constructs a presentation based on the credentials that satisfy what the verifier is asking for. And then after it, the cryptography is verified in the presentation by the verifier. Note that the verifiable credentials are not given. The presentation is derived from the source credential. This is different from some other credential methods. In the basic and up until Monday, in the data integrity proofs that are used by the W3C community, the actual credential is passed from the holder to the verifier along with some extra information. In the case of AnonCreds, that is not the case. The verifiable credentials are held by the holder and not given to the verifier. What's given is a derivation of those verifiable credentials unique for this presentation only. And that is what is sent to the verifier. So in this flow, the verifier creates a request. The request is sent via some protocol, some interaction to the holder. The holder uses the presentation request to search through their wallet to find the credentials that satisfy that proof. Once they have those credentials, they pass the credentials plus the presentation request to AnonCreds, which generates the proof. It does all of the math and so on. That presentation is then sent over to the verifier. The verifier processes that using AnonCreds code. So again, it passes the presentation plus the request over to the AnonCreds library, which processes it and verifies it. And then the verifier should do business rule validation after. So there might be some additional. So all this does is says that a cryptographic verification checked out, that the cryptography that was included in the presentation worked. However, does this meet the business rule validation? And we'll talk about why that may or may not be the case. Outside of the realm of the cryptographic verification. So those are the steps. Hope that makes sense. Okay, let's talk about the request presentation components. This is the trickiest part of the lab. The folks that implement Traction made it easy for us. If you use the same credential that I used and suggested you use in lab 1, it'll be easy to do a presentation request, but we don't have a presentation request builder at this point. So you got to be playing with JSON. So requested data, you can request attributes, which are groups of attributes from a single source credential. So you can request multiple sets of attributes, and each set must come from a single source credential. As well, you can request predicates, and each predicate is a true-false numeric expression on a single attribute. So built from a combination of an attribute, a value, and an operator that checks the relationship between them. The only operators that can be used are these ones. So predicates, I'm now sort of lowering the bar of what you can do with predicates. Must be an integer and must use relationships like this. So there are relatively limited use cases for them. But the big one is a crucially important one, which is older than, dates, expiry, amount of money in a bank account. So there are a bunch of ones. The date ones are crucial because dates quickly become correlatable identifiers. If you can combine a date of birth with almost any other personally identifiable data, you wind up getting a unique identifier for a person. And so that's why these predicates, while limited in function, are pretty important. With each of these requested attributes and predicate, there are restrictions, and restrictions are and or logical expression about the acceptable source credential. So this is what's saying, I will accept a credential from this issuer or this issuer or this issuer, but that's it. Or I will accept a credential using this schema from any issuer. And we'll talk about what that involves. And then finally, there's revocation involved, and we'll talk about that later. But basically, revocation allows you to request a proof of non-revocation for some or all of the source credentials. So you can put revocation on a certain credential or a certain set of attributes that will be satisfied by a credential, or across all of them. And you can use a time period for those. So you can say, hey, was your credential valid on June 26th when the accident occurred? So this is a back in time proof that your credential was valid. I'm offline. Another one is the offline use case. I'm offline as a verifier, so I can't go check the VDR right now, but I do have these sets of revocation registries. So as long as you give me one of these, I'll be able to check yours. This is an example. This is the example you're going to see in the tool, the traction tool. So we've got a name, we've got a nonce. Those not familiar, a nonce is for preventing replay attacks, so that somebody listening in on a conversation between a holder and a verifier can grab the presentation request and then use it as their own. By putting a nonce in the request, it makes the presentation from the holder completely unique and can't be reused. Requested attributes, these are the arrays. So I'm saying I want student information to be given name and family name. I could have multiple of these when I'm requesting multiple credentials. And then the restriction is where I specify what credential I'm permitting it to come from. And then a predicate here, I'm saying I want to check on expiry, and I want, I'm using today, essentially, a few days ago when I wrote this, and the relationship is greater than. So, and again, I'm going to use this same restriction. So I'm going to pull an expiry date, and I'm going to check that as of today, it is not expired. I won't get too deeply into this. The restrictions allow you to restrict on all of these 8 items. So you can restrict on a certain schema publisher, a certain schema itself. This shouldn't say did. This is the schema identifier. The publisher identifier should be the did. You can have a certain schema name, and you can have a certain schema version. So you can use any combination of these. And then likewise, so that's all based on the schema. You can restrict it to a specific issuer, a specific credential definition. So you can restrict it to the certain issuer of a certain schema. And then you can also say the credential must have a given attribute name, and the credential must have a given attribute name, and it must have this particular value in it. So you could do something like saying, oh, you know, a passport that has a credential attribute province and value British Columbia. So you could say, oh, I only want to allow people to prove using their passport and that are from British Columbia, for example. So the ands and the ors are here. You've got ands across the group, and you've got an or here. So you can use that for reference if you need it later. Data predicates, as mentioned, I've gone through this a few times. Either date int is the common way to do dates. So this, and there's your comma representation of that. Or you can use Unix time is a good way to do this as well. So this is the Unix time is the number of seconds that have passed since January 1st, 1970. So that is when this workshop started. This was the value of Unix time at that. This is what it actually looks like. And again, example. Here's an example of not expired. Here's an example of older than, and it just shows you which expression to use. So both of these represent, this represents 19 years ago today, this represents today, and then this tells you what which p value, which p type, which expression, which logical expression to use. Does not work with a string date. I think I've said that enough. So once the presentation request has been provided, the holder generates the data. They receive it via some protocol. They search in their secure storage, their wallet, for credentials to satisfy the request. So there's basically a mechanism that is not officially part of AnonCreds that can be used, but basically it's up to the implementation to find all of the source credentials that satisfy each attribute group and predicate. They may come from the same credential, so you may have multiples coming from the same credential. That's perfectly valid. If you have not found, if there's none found, or if multiple credentials are found, business logic would dictate what to do. So you could automatically send the latest. So you've got two credentials that satisfy, send the latest one. Or you could pop up a message to the user saying, hey, you've got two credentials that satisfy this. Which one do you want to use in this case? So business logic would dictate how you deal with multiple credentials that deal with it. You may need to get credential definition and revocation registry data in case the presentation has to prove non-revocation. And then with all of that data in hand, you pass it to an AnonCreds library and you generate a presentation from the request and source credentials. Basically, it creates one proof for every source credential, one presentation for every source credential. And then after it does that, that includes a proof across all the encoded attributes. It shares the raw values that are being revealed to the verifier. A proof of non-revocation is generated, and then a proof per predicate is produced from the source credential. So if I have a date of birth and an expiry one, both of those would be generated and attached. So you may have up to 4 proofs, or you may have many presentations across this. One for all of the attributes, one for the non-revocation proof, and then one for as many predicates as are being asked for. And that's each source credential. And then finally, there is an aggregate proof across all the credentials that verifies that the same link secret is used for all of the source credentials that have been provided. So that's one extra proof that is included in the presentation. Okay. And then there's verification. So verification, I put down as 4 levels. Cryptographic verifications, do all the proofs verify. So I hand this presentation over and we make sure that all of the cryptography matches, that we pull the data from the VDR, we make sure that all of the zero knowledge proof predicates, the non-revocation proof, the aggregate proof, all of them work. Next, we verify again in AnonCreds, was the presentation request satisfied? So cryptographically, they may have given us a totally different presentation unrelated to the presentation request. So we want to make sure that all of the groups were satisfied, the revocation intervals were satisfied, and so on. So this is more a logic check. The cryptography has been checked. Now we're checking that the presentation request was adhered to. Next, we may have more verification done, in particular in the agent framework, verification of the presentation against the request, unrevealed attributes, raw values, other things there. And then finally, the thing I wanted to underline, most importantly, business logic. I've done cryptographic verification, but is the presentation sufficient for the business purpose? And the most common one there is, do we trust the issuer? If in the presentation request we said I'm going to only accept from these issuers, which is typically what we do in a paper credential world. We say, oh, I want to see your driver's license. So we only accept them from a certain issuer. If we specify, if we want to get a education credential from any university in the world, we're going to request a certain schema or certain attributes be included. But we won't know until we get the presentation who the actual issuer is. And as a result, we may then want to find out, oh, have I ever heard of this university, and do I trust this university? And so that's where we wind up with a business logic decision. Do we accept this presentation for the purpose of the business? Trust the issuer handling. Oops, I just did all this. Pre-verification by putting it into the presentation request or post-verification. And that may be done through a local list built into the application. It may be based on a trust registry. You're going to contact a service that says, oh, here's the issuers you can trust. And here's the identifiers and the issuers you can trust. Or it could be done dynamically. So when you get a new user, you pass it to a human and you say, hey, can you check out this issuer and see who they are? And then they would do some research and decide and update either the local list or a trust registry. So tricky issue here, and one that definitely needs to be covered in any verifiable credential usage, whether it be AnonCreds or any other. Trusting the issuer is a interesting issue when you want to accept credentials from a wide variety of sources. So the last lab we have is issuing credentials, or lab 3 is presenting. Sorry about that. Another typo in the instructions, but anyway, we'll get there. Again, instructions are here. Bitly AnonCreds lab 3. So take a few minutes and give it a try. Let's get my things up here. So this time we're going to the verification. We're going to create a presentation request. I have made it so that this default one that it shows here matches exactly my example. So I've got a proof request. I'm going to put a nonce in. I'll change it. Put a bunch of numbers in. It's version 1 of this proof request. Again, that's just a user setting. I'm going to want student info attributes called this, and it's got to come from a schema with a schema name student ID. And then I'm going to check an expiry date. I'm going to make sure that the credential has not expired as of today. So I'm going to change this value to 0531. And again, it's going to come from the same credential. I'm going to pick a connection to send it to. I'm going to send it to the BC wallet. I don't think this does anything yet. This is being worked on right now and by the BC Gov team, but I'm going to add a comment to it. Workshop PR presentation request. And now I'm going to submit that. And over here up pops a notification that I have a proof request. Whoops, it says I don't have one available. What happened? Oh, I'm sad. So not much I can do but to decline that. So I'm going to decline that. I'm going to get a status here when I refresh saying this was abandoned. So I got a note back from the wallet saying, hey, I'm not going to present. I'm going to take a quick look at my credential definition. Or no, let's go to the schema. Student under student space ID. What? I suspect this is not going to help, but what the heck, I'll try. So I'm going to reuse this proof request. I'm going to copy this existing one by doing that. I'm going to. Oh, I wonder if it's this. I'm just going to remove this predicate. Whoops. Oh, this is fun. Okay, there we go. So I'm going to remove that predicate and I'm going to try it again. Try 2, see if that's what it is. Oh. I better pick where I'm going to send it first. Nope, I'm still not able to. So I don't know what I'm doing. Oops, I sent it. Okay, that's interesting. So I did send it anyway. I must confess I haven't done that before. So in this case, it does allow me to look at my presentation. So I've got my requested attributes. I've got my presentation. This is what I did want to show. This is what a presentation actually looks like. So I'm revealing family name and given names. I've got a bunch of cryptographic information here, and then I've got the value of related to the revealed to the other attributes that are not revealed. This is the aggregated proof, which is very, very long. And then finally, I've got my revealed attributes, my raw and encoded. And I'm not sure, I'm not seeing immediately where it's saying the status of it, but normally you would see a status of it being verified or not verified. Okay, not ideal, but hey, we keep rolling. We've presented the proof, we've done this, the holder provided it to the verifier, they did reading, so you get to play with it. The verifier gets to pull the data in and verify the proof. And that's it. I was going to do this before the break. I think I will do this, but why don't I do this after the break? Why don't we take 10 minutes and we'll come back at the top of the hour to continue on, and I'll go through that. So the question from Stefan about why does the presentation include the not shared data? That is to show that is a blinded verifier, so there's no way to derive the data from that, but it shows that the signature is valid, so it is used to verify. You basically are sending enough information to verify the entire credential, but you're only revealing certain attributes. So you only provide the data that you are actually revealing. So it allows the full verification of all of the credential, but revealing only the attributes that you want to reveal or were asked to reveal. There is actually a feature in AnonCreds where the holder can choose to not share a piece of data. So the presentation request comes across, the verifier, a holder generates a presentation and says, I don't want to, or sorry, gets the offer, says, I don't want to reveal my last name. Generation is done and that's not revealed, but it's still verified. So that data still goes back to be verified. That is another reason for the business level verification. Suppose the verifier has got to, the holder chooses not to reveal all of the data. Okay. Let's take a break and we'll be back at the top of the hour. I'm going to turn off my mic for a bit and be back in a moment.
Thanks, Stephen. We're going to take, I believe, a 7 or 8 minute break, and we'll see everybody at the top of the hour. Also, we are live streaming this, and it will be on the Hyperledger YouTube. If, like, Dave Bigsby has to split, he can catch up with what happened after he leaves. It'll be on YouTube a little bit later today. And all of the decks, the lab documents are on the wiki page, and I'm going to post the links again in a second.
Hey, folks. Let's see.
Hey, Stephen, we have a question.
Yep.
Why does the presentation include information on the not shared information? Parentheses, example, date of birth. That's from Stephen.
Yeah.
Stefan, sorry.
Yep. So that is to enable verification of the full credential. So make sure that you're sharing the proper credential, that the signature can be verified across the entire credential, even though you are not revealing the actual value. There's no way to use the information that is shared to derive the value. So that is not a hash of the date of birth or something like that. It cannot be derived from it. So it's purely for verification purposes. All right.
I think we can get started in about another minute.
Okay.
Give folks to get back. And for folks following along, Marco asked about chat history. Generally, we don't post the chat with workshops, but the questions we've had here have been pretty amazing. So what I will do is when we post the video to the wiki page, I will put a link to a PDF or a text file of the Q&A and chat. We don't want to lose these questions, and the answers are fantastic. And thanks again to all the folks on the workshop who've been pitching in and helping out, answering some questions for folks who are new or getting up to speed on AnonCreds. This has been great. So Marco, I'll try. I can't do it right now live. We're not using the webinar features of Zoom today, but we will get that posted to the wiki page, and the link to the wiki page is right above your comment. All right,
Okay.
Stephen, whenever you're ready, buddy. We're still recording. You're good.
Okay, let's go. Okay, I'm going to talk about revocation briefly first as the next topic. So there's no lab associated with this, but we'll just go through it. So revocation involves a couple of things. One is the issuer deciding it needs to revoke a credential. So it's issued a credential, it decides, hey, I need to revoke it for some reason, and it writes revocation data to the registry. And then during the holder verifier event, the presentation request and the presentation, a proof of non-revocation is generated. The holder reads the revocation data off the registry for its for the credential type it's been issued, and it generates a presentation, a proof as part of the presentation to go to the verifier. Again, the reading is done by the verifier to do the verification of that proof. So why would an issuer decide to revoke a credential? Main thing, a very common use case is the data is no longer accurate. So automatically you think the easiest and most obvious is something like you've got an address in the data and that you change the address. Anything in the credential has changed, any material data has changed according to the issuer. They decide they want to revoke and possibly reissue the credential. So that's one. The holder's authorization to use the credential has changed. This is the one people automatically think of because they think of revocation as somebody's done something bad and we need to take things away from them. So if it's a driver's license and the driver is no longer allowed to drive, they've lost their driver privileges, the issuer would revoke it. That actually is just an example of the data change. So it's a much broader category than you've done something bad and we need to take it away. And then the other one that is interesting that people forget is we're not always perfect. We don't always issue a credential correctly. And so this is one, I got made aware of this by a government person that basically said, well, sometimes mistakes happen and we always need a way to correct them. And so that makes it almost any credential needs this ability to be revoked. However, expiration can be handled separately without revocation. Put in an expires attribute as we did in that example one, and you don't have to revoke for expiration. The verifier has to know they need to request a check on verification. Revocation is a unilateral action by the issuer. There need not be any involvement of the holder. The issuer just says, I'm revoking this, end of story, and they revoke it. They take the action. There may be a notification to the holder. There may be even a notification that says, hey, you can get a new credential. And then you go through that process to issue a new credential to the holder. The only way that can happen, a notification to the holder, is if there is a relationship somehow between the issuer and the holder. And this is where DIDComm, we think DIDComm is so important. DIDComm becomes a trusted channel between the issuer and the holder. If the issuer today sends an email or an SMS to notify the holder, hey, we revoked your credential, click here to get a new credential. Nobody is going to trust that. Nobody trusts email and SMS for those types of things. With DIDComm, you actually have a trusted channel for messaging between an enterprise and their customers. And we think that's a really important part of DIDComm. Separate from AnonCreds in the topic, but this is one really good example of why having a lasting connection, a relationship between the issuer and the holder can be helpful. Revocations are published somewhere accessible to the parties needed them. That's the VDR. In some cases, the verifier can detect revocation in subsequent presentations. So the revocation is published by the issuer, and then the verifier goes to present a credential in the future. They can detect, the verifier can see that the revocation has been made, that the credential is no longer a valid credential. The holder can still produce a presentation and can pass it along, but the verifier will know it's been revoked. That's the key. Depending on the revocation scheme, and I'm talking in general across AnonCreds and other verifiable credential formats, a verifier may be able to monitor revocations, and this is a bad thing. We think this is a bad thing. It can be a feature in some use cases, but in general, it's a bad thing, which is I give you my identifier for my credential. You then monitor the revocation to see if it ever gets revoked. And so ongoing monitoring occurs by the verifier. AnonCreds does not allow that. And that's the difference between AnonCreds and some other revocation schemes, but just be aware of that difference. It is not possible for the holder to revoke a credential. They can delete it, they can decide not to present it, but the holder cannot revoke a credential. That is the domain of the issuer from a cryptographic perspective. That was a question. AnonCreds revocation, this is the most complicated part of AnonCreds. Oddly enough, it's the add-on feature that you think of. Oh yeah, by the way, can we do revocation? Yes, but it is complicated. The 1.0 scheme works, but it is not scaled very well for huge use cases, for nationwide use cases. It's not ideal. It's pretty easy for the holder and verifier. It's basically built into AnonCreds library, and there's not much to be done, but it is a lot of work for the issuer. This gets into how it, so basically that feature that I mentioned, I hand over a credential from the holder to the verifier, and then the verifier can monitor it on an ongoing basis. That's what we want to avoid. And so what is done is an accumulator-based non-revocation zero-knowledge proof is generated. So there's a little bit here about how that happens. I'm not going to get into that. I don't think in this situation. Glad to go over this if people want to ask me questions later and want to have a follow-up or something on revocation, and then one other topic that I'm going to mention, we can get into it. But basically, this is the gist of how the zero knowledge part of it works. Issuer revocation activities. For issuers, the frameworks are crucial in simplifying the activities. In Ares Cloud Agent Python, for example, the one BC Gov uses a lot and did a lot of the initial creation. When a lot of the complexity of managing this from a issuer perspective is handled within the library, and so it's not a big deal to use. What a credential when creating a credential definition, remember in the setup we created a credential definition. We use the flag use revocation, and we specify a registry, a revocation registry size. That's going to be a number between 1,000 and 10,000, something like that. On issuing credentials, every time we issue a credential, we have to record the revocation ID of the credential and associate it with who we issued it to. When needed, we revoke a specific holder's credential by using the revocation ID. We invoke a routine that says revoke credential 17296. And then at some point, we publish those revocations, either as they happen. So as soon as we announce we're revoking it, we immediately publish them, or we do it periodically. If the use case allows for it, we might only do it periodically. So a particular DMV, driver's license manager might say, oh, I'm going to publish all the revocations of driver's license once a day. So anytime an address changes, it'll be triggered the day, within 24 hours. So that may be enough. That cuts down on the number of publish operations, reduces the load on a ledger. But it's a business use case. You can decide to do it immediately as it happens or periodically. So those are the steps the issuer does. For holders, when they receive a credential, they retrieve what's called a tails file in AnonCreds. So that is related to the revocation registry their credential exists in. When they create a presentation, they retrieve the state of the revocation registry from the VDR. So basically, the state simply says, here's the list of credentials that have been revoked. Out of all of the credentials that have been issued, here are the ones that have been revoked. And it's just an index. It doesn't say whose it is. It's just simply an index. The 7th, 9th, 12th, and 3,000th credential in a registry have been revoked, and all the other ones are still valid. Once they have those two pieces of information, AnonCreds does the rest and generates a non-revocation proof to include in the presentation. So pretty easy. The tails file is a static file created at credential definition creation time. They only need to download it once, and it just sits there. Finally, for the verifiers, the holder retrieved a particular entry, the particular state, usually the state as it exists when the presentation was created. The verifiers would retrieve that, the one the holder used. They would retrieve that from the VDR, and then AnonCreds just handles the rest. They pass in the proof, they pass in the RevReg entry, and the verification is done. They get no correlatable identifier, and they have no way in the future to monitor if that credential happens to be revoked sometime in the future. If they want to know if the credential's been revoked in the future, they have to ask for another proof from the holder. So it's a consent issue, and why we don't think being able to monitor revocation state is a good thing. the frameworks hide the complexity. So there's a whole pile of complexity. I said that a revocation registry of limited size. A size means the number of credentials you can issue. When all the credentials in a registry are used up, you have to create a new one. So if you've got a RevReg side of 10,000, you can issue credential 10,000 times, and then when you hit 10,000, oh, you've got to create a new revocation registry and then track issuing through that. ACAPI keeps track of usage, detects when a revocation registry is used up, and creates one ahead of time so that there's no stopping when you hit 10,000. So basically at the start, it creates 2 revocation registries. As soon as the first one is consumed, it creates a third one and starts consuming the second one, and so on. So you never have a point where the issuer has to stop issuing because there's no revocation registry. You stay ahead of that. The tails file per revocation registry must be published for the holder to download. So ACAPI handles putting it to the place specified by the issuer, usually using something called a tails service. And then finally, ACAPI, when you publish a revocation batch for a type of credential, so given a student ID credential, you say, okay, I want to publish the batch, publish the revocations. You might have 10 revocation registries because you've issued 100,000 credentials. ACAPI takes care of walking through all of them and publishing all of the transactions necessary to publish those revocations. So all of that, when we first implemented this, the end user, the issuer had to do all of that work. That now is all embedded in the framework. And so that's a crucial piece of simplicity in using it. Yeah, the tail server is kind of interesting. The tail server could be either hosted by the issuer or could be hosted on a shared service. There's no correlation. So the issuer, it's not what you would call a call home factor where the holder has to call back to the issuer to get something because the issuer already knows they've issued it to the holder, so there's no extra knowledge gained. So the issuer holding it is fine. Why not simply update a record with expired or revoked? So the question, so you can't update the credential itself. The credential has been signed, held by the holder keeps it, and so on. So you can't simply update the credential itself. If you could update a record and make it available, but then that has to be queried somehow. And so that gets back to a call home. The verifier has to call the issuer, hey, has this credential been released? And now we've added the issuer to the whole verification process. We want to keep the issuer out of that process. So that's why you don't use that type of mechanism. Limitations of AnonCreds 1.0 revocation. The tails file basically holds a set of prime numbers for the revocation registry, one for every entry. The problem is that the size of that increases linearly with the number of credentials. So with 1,000 credentials, it's a 250K file. With 10,000 credentials, it's a 2.5 meg file. That becomes too large. For a mobile, your limitation is your mobile wallet commonly, your app that's on your phone. Obviously, if it's a enterprise holder, a business that has its own business wallet that's on a server, well, that doesn't matter. But if you're dealing with a phone, 2.5 meg file is getting large. You don't want anything larger than that. And so that constrains the size of it. So practical limit is about 5,000 to 10,000 credentials per revocation registry. Now, you can have many revocation registries for credential type. So it's still unlimited number of credentials. It's just you have to have a new registry every time you hit the limit of the registration size. And so that's where that limit comes from. Additional details, handling of the presentation. So I'm just going to highlight these and request that if you want more details of these, note this slide and ask me what you need to know. Revocation interval is provided. There are semantics about it, and there's best practices that should be followed. It gets a little tricky to understand, and so presentation request interval is an interesting topic. Then there's one other thing, which is when you have revocation, you request revocation, but the source credential doesn't support revocation, or you don't request revocation and it does support it. How is that handled? And the basic answer is that the presentation should always work. So if you're requesting two credentials, sorry, you request revocation for both of them, but only one supports revocation, that presentation should still work. And that's the way it is designed to work. So those are some tricky subtleties that you can get into, and happy to have that, happy to share more on that if people are interested. There you go. Need more information, let me know. Feel free to follow back up with us with, on Discord or whatever, to know more about that. This is where I plan to take the break. We're going to jump into this. I'm going to jump ahead, and Rodolfo, you're coming up very soon. I am not going to do this section. So this is another really fun section, and I really wish I could have done it because it could have added some interest, and maybe at the end, if people are interested, we could do it, or I'm happy to do another session. There's a link here to slides for this, and I recently did this at a conference, the Open Source Summit for Linux Foundation. Basically what this does is it uses high school math to do to explain how zero knowledge proof works, and it quite a very accessible way, as long as you've completed high school math and you did reasonably well and you sort of remember it, how zero knowledge proofs work and why they are valuable to use. So I quite like this was first presented by another professor I saw, and I've adapted it and adjusted it, and I think it's a pretty good presentation, but we don't have time for it. I included this in case we did, so we'll see.
Stephen, what we might do is get you on the Identity SIG calendar to do this. I didn't get to see it in Vancouver. I'd love to see it. So we'll work that out, and we'll let folks know when that's going to be.
Sure. Yeah. The recording from Vancouver is posted. This link actually goes right to the part on this section. So, okay. Ledger-Agnostic AnonCreds. So historically, Hyperledger Indy. So AnonCreds began as a tightly integrated stack, all within the Hyperledger Indy project. So the work evolved from what IBM did. Evernym and Sovereign did a pile of work on it, donated it Indy as a whole into Hyperledger and the Linux Foundation. There's a whole bunch of instances of Indy that have been spun up publicly under various governance policies. Indy was an all-in-one. It included the ledger, it included the VC format, AnonCreds, and included agents. The agents were extracted out essentially in 2018, and that became the Hyperledger Aries project. In 2022, AnonCreds was extracted out of Indy and made into the Hyperledger AnonCreds project. So Indy is the ledger and an interface to talk to the ledger, permission to write, open to all, public to read. While we were doing the specification work, we determined that in the Hyperledger AnonCreds group, we just determined that there was almost nothing tying AnonCreds actually to Indy. It is more a it was more that it was convenient to put it in there and the libraries used it. And in fact, what I was really surprised to discover was people would come to me and say, hey, by the way, we're using AnonCreds, but we're using it with Fabric. And we're using AnonCreds, but we're just using a database. So all sorts of people already had just taken AnonCreds as it existed and put some shims around it to make it independent of Indy, to use it with different ones. So when the AnonCreds specification work evolved a little, we decided that was the goal of the 1.0, was to make AnonCreds completely independent of Indy. And so that's where the concept of the term ledger-agnostic came from. Turned out there was one data element that was completely Indy specific, but could be easily eliminated. And there was a little bit of work around revocation that had to be cleared up. But other than that, making it ledger agnostic was rather easy. Basically, for those familiar with DIDs, the mechanism is the same. You basically have various VDRs, and you have a registration method and a resolver method. And so when you have an identifier in AnonCreds for a schema, you pass it to the resolver. It looks at the identifier type and then figures out which VDR it's on, retrieves the object and passes it back. AnonCreds has no idea whether it's on an Indy network, a Czech network, a Cardano network, doesn't know. It just passes the identifier over and the resolver figures it out. Likewise, a registrar is the same, registering. This is writing, publishing to the VDR. You pass in the data with where you want it to go, with an identifier or an indicator where you want it published, and it gets published to the VDR. So that's the architecture. And with that, the legendary Rodolfo is going to take over and lead you through a demonstration of that and the use of it. So I will stop sharing. You are there, Rodolfo, right?
He was a second ago.
I didn't expect that.
As I scroll through 5 pages of names.
I don't see him.
Maybe he got bounced. Let me, he hasn't said anything on Discord.
Well, that's wild.
Hang on, he might be dialing back in. Let me. Yeah, he's out. Okay.
Well, that's fun.
That's all right. It's a workshop. We'll route around. Oh, he's back. Okay. Hang on, Rodolfo. I got to make you a co-host. Rodolfo, you're good to go.
Okay, sorry for that. I think I lose all my internet connection. I'm on the mobile 3G, so let's see how it works.
All right, you ready to go?
My introduction. Yeah, I'm ready to go. Yeah. So my name
Take it over.
is Rodolfo Miranda. Can you hear me? Yeah,
We can hear you fine. Yeah.
Oh, good. So my name is Rodolfo Miranda from RootsID. So I've been in that self-sovereign space for around 2 years. And I come from a blockchain community. In my case, it's the Cardano blockchain community. That's why I'm going to talk a little bit about how you can use AnonCreds in a different blockchain than Indy. So I say blockchain, but actually I should say VDR, because you can use any storage as a VDR. Let me share my screen because I would like to go to the source document, that is the spec. I'm going to show that my desktop. Can you see that? Okay. Okay, this is the spec. Good, great. So this is the main document. I think everything that Stephen mentioned is written here. All the technical details, how the AnonCreds work, how you should implement is here. It's a huge document. And I won't go over that, but I gonna point to the introduction, where this is this nice plot here, this graph, because I will try to explain why we need a VDR and why we need to maybe replace the VDR. So in this plot, you see the issuer, holder, and verifier, the nice three participants of the identity solution, and you have the VDR. Roughly speaking, really simplistic, we can say that in the issuers and holder, we store the private information. And on the VDR, we store the public information. So since we are dealing with cryptography, you know that every time we talk about a key, we're talking about a key pair. So a key pair is composed by the private part of the key plus the public part of the key. So in this scenario, the private keys go to the issuers and to the holder in the link secret, and the public part represented with other information and posted in a specific format goes to the VDR, right? You have the private and the VDR. So we know that the private part is really critical. So if you lose your keys, or if your keys are compromised, you know that maybe the holder lose the keys, they lose the identity. Maybe if the issuer or compromise the keys, maybe all the credentials that the issuers have issued are compromised as well, because some malicious actor can create and issue new credentials. So the value of the other credentials maybe became to 0. So, and because of that, we tend to minimize the importance of the VDR, because VDR only have this public information we try to make available. But actually, in order to verify a proof or a claim, we need two things, right? We need the signature, and we need the public part of the key. So if one of those are missing or incorrect, the proof is not going to be valid. So in order to that, one of the key features of the VDR is that the public key should be always available, right? And also should be the correct public key. So these are the two main characteristics that the VDR need to have, like to have all the objects or the public information always available, and this information cannot be modified in time. So always have to be the same. So as you see, the VDR have a critical is a critical component as well, right? And you need to decide which VDR you want to use. For example, if we also call that the VDR is like a trust storage, right? Because the members of the user of that system need to trust that storage. So, for example, if you wanna, I think on the chat today, someone mentioned the Ethereum blockchain. So, if you wanna build a system for the Ethereum community, it makes totally sense to use that blockchain, the Ethereum blockchain, as a VDR, because the member of that community already trust that blockchain. However, if you go to maybe a government and you start explaining that you're going to use Ethereum, maybe that won't be a nice option, right? Because the government may not decide to trust that option. VDR can also be a database, and you may find use cases that a database is a valid option. So that's why selecting a VDR or making a VDR as an option on this aspect was one of the principal goals, instead of only using the IND option, right? How the spec deals with different VDRs. I think in the spec there are 3 things to deal with, to make the spec agnostic to IND, maybe agnostic to any VDR, specific VDR. Is define 3 things. The first one is a VDR needs to implement two two operations. One is to write into the VDR objects, and we call write, or we also call publish offset to the VDR. And we also need another operation that is read from the VDR. We need to mention an operation to read objects from the VDR, or we also call resolve objects from the VDR. The second thing that is defined on the spec is the objects itself. So there are four types of objects. One is the schema, the credential definition, and the revocation registry with all the entries. And the spec is really specific in how those offsets should be formatted. So if we go to the spec, we can see, for example, for the schema, that the schema need to have this specific format. To have an issuer ID, a name, a version, and all the attributes that the schema is going to have. And if you go to maybe the credential definition, you're going to have also all sorts of different properties that the schema have to have, that the credential definition have to have, like this one: issue ID, schema ID, type, tags, values, the primary, all the fields that are on the schema, and so forth. So there is specific details of how you need to format a credential definition and each of those options. And the third thing that is defined on the spec is a registry. It's a registry of AnonCreds method. An AnonCred method is just a definition of how to use a specific VDR with AnonCreds. So, for example, in this in the registry currently, we have several methods defined. One is, for example, the did-indi is how you use indi with AnonCreds. That's how have been forever implemented. But you also have how you can use a web, like a web server to store those objects. Later on, Patrick's gonna give you a demo how to use the web server as the AnonCred method. We also have, for example, the check. The check team implement check is a platform, identity platform that use the Cosmos blockchain. So they implement, I think it was the first to implement the AnonCred method in a different ledger. So they build a full spec. I'm gonna point to that. Let me clean that. So they build a full spec of how to use checkd as an AnonCred method. You can go. You're gonna find all the links on the slides and on the wiki after the workshop. And we also have the Cardano that is. I'm gonna explain a little bit how it works for us to build the Cardano AnonCred. But if you want to build a new method, you just need to define how it's going to work for your VDR, submit a PR in that repo. The working group of the AnonCreds is going to review the PR. It's going to validate that it's complied with the spec, and when it's merged, your method is going to appear here, so everybody can see and use it on your ecosystem. So let me show now, my experience, or our experience as RootsID in building a new method for a particular blockchain that is the Cardano. So that's going to give you, like, for you a reference how it takes to build a new VDR that is not really complex. So if you go to the Cardano, you're gonna find a link to our method. I think it's here. What we did in our case is we meet with several players on that community that works with identity solutions, and we try to meet periodically to define this specification, that is how we should write objects into the Cardano blockchain. So we meet and try to build this spec. the first things that we need to define is how we're gonna store the objects on the blockchain. Cardano is a public permissionless blockchain. So we know that in every transaction of, this is a cryptocurrency token that already runs on the blockchain. So in any transaction, from a token from one wallet to another wallet, one address to another wallet, we're allowed to put an extra information on the transaction. So once the transaction is validated and minted in a block on the blockchain, all that information also goes to the blockchain and is anchored on that. So now you're gonna have this transaction metadata on the blockchain that is gonna be public available and also can be verified that is mutable, right? They cannot be changed. So we decided to use that option to store the object, the AnonCreds object. We also need to define how we're gonna reference that object. We use one spec, one format that is called DID link resources. That is a way to link some resources to a DID. In that case, takes the form of this one that says, that says you have the publisher DID. In our case, it's the issuer DID. You have the path of resources and an object ID that is a unique identifier of the object. Since we are using a transaction to store the object itself, we decide to use the transaction ID as the object ID. So that's going to be really easy then for query for those transactions. After that, we define how the objects is going to be composed. We actually going to use the AnonCreds object as is defined on the spec, but also we are adding extra information such as the type of the object, who is the issuer, and that is really important is the publisher signature. So we have an extra step of validating that whoever submit the transaction is also the owner or the controller of the issuer DID. We did that for all the objects, the schema, the credential definitions, the revocation registry, and also we had to deal with some nuances of the blockchain, because in the blockchain you have to deal with latencies, we have to deal with transactions, with fees, with how the consensus protocol works. So we define everything on this document. And then we put the hat of developers and implement some reference implementations in code. We did that on Python, on TypeScript. What we wanted to go further that and have a real implementation. So we pick one of the frameworks, ARIS frameworks, that allows us to use the new AnonCreds specification that is Ledger-Agnostic. So we went through them and using the ARIS framework JavaScript. And I'm going to show you right now a piece of code. You don't need to understand the code. Let me clean that a little bit. I'm going to show you a little bit of code, how it takes to use. Because once you have a framework that allows you to use different VDRs, it's really simple to port one VDR and use a different VDR assembly. In that case, as I mentioned, we use the ARIS framework. That we import that framework into our code. We also import our reference implementation, the Cardano AnonCreds registry. We import it to the code. And then when we launch the agent, this is the ARIS agent. It's a command to launch the agent. We tell that the AnonCreds that the agents should use is the Cardano AnonCreds. that's all that we need to do to use the ARIS framework with Cardano VDR. The rest of the code is just the same for any VDR. This is a script that what it does is create the link secret. It's also create a DID for the issuer. So everything is mixed here. It's just a sample. Create and publish the schema. And the publish means it's going to be published into the real blockchain. Create some publish credential definition into the blockchain. And then it's going to wait for some blockchain confirmations that are needed. And it's going to resolve those. I'm going to go and read those objects from the blockchain. Let me show a little bit that. The example may be a little bit silly, but want to show you what it does. It's creating, you see, creating the secret, creating the issuer DID, and then creating and registering the schema and the credential definition. If you see, the ID of the credential definition have this format that is the DID of the issuer / resources, and this long identifier that actually is the identifier of the transaction that we use to anchor the data on the blockchain. So you see that now that is waiting for the blockchain confirmations. That needs to be done because I don't know if some blockchain, the way it works is they mint several blocks periodically. In that case, it's every 20 seconds. So you need to wait for some blocks after the one that you mint to make sure that this one is really validated by all of the nodes of the Cardano blockchain that are doing this consensus protocol. So now you see that the minute passed and we have this, we are able to resolve all the objects. This is as Stephen showed today, you can see all the details of the objects like this number, big numbers. This is actually a way of encoding all the public keys of the credential definition and the credential itself. So if you go to that, this is the schema ID. Let me show, I'm gonna show you credential definition ID. And as I mentioned, this identifier, this string is actually the ID of the transaction that was ported into the blockchain. So if we grab that, I'm gonna copy that. And if I go to a blockchain explorer is actually a service run by any party that go and query the blockchain to see what's there, right? You may find blockchain explorer for Ethereum, for Cardano, from Bitcoin, for any blockchain. So if I paste this ID here and I'm gonna search, I'm gonna find all the details on the blockchain. This is a real blockchain. It's a testnet. It's free, but it's a real blockchain that is over there. So you're gonna see timestamp. You're gonna see actually the fees, how that cost, because every transaction has a fee. And this is 40 cents of ADA. This is like 10 cents of US dollar. But you also can go and see the metadata. And if you look at the metadata, you're gonna see all the details of this is the credential definition with all also the extra data, like the signature of the issuer. So just to give a little summary of what I'm trying to explain here is that now you can use any VDR, the VDR of your choice to in a system that with AnonCreds. So how you choose the VDR? You need to choose the VDR that really provide trust for the members or for the users of that system. You have a registry with many AnonCreds already available, but if not there, you can go and build one because it's gonna be, it's not so hard to build one. So thanks, and pass back to you, Stephen.
Thanks,
Awesome.
Rodo.
Thank you.
Stephen, you're up.
Whoops. I am. All right, let's keep going. We're going well. We've got a few things left to go. I should highlight, I didn't really introduce Rodo, legendary in the community. He does awesome work. And Patrick, same thing. Patrick just keeps coming up. The two of them just keep coming up with new and interesting things that just others hadn't even thought of. And boom, we're able to use them. We're demonstrating both of them today, and I'm super excited about that. Okay, let me get to my presentation. Where did it go? Did I close my browser? I never close my browser. What? Well, looks like I did. Hang on one sec. Sorry about that. There it is. It's in full screen mode. Okay. We're going to jump to a topic that for insiders in the community is quite interesting and controversial for a long time, and yet pretty weird. AnonCreds in W3C VC data model format. So long controversial in the verifiable credentials community. AnonCreds does not use the W3C VC data model. Several initiatives were started over the years. As mentioned, both the VC data model and the AnonCreds goes back 6-7 years. Several initiatives were started to align the models. ZKPs are specifically mentioned in the W3C VC spec. AnonCreds had some work to align the models, and it turned out that the most significant one, which was a thing called rich schemas, fizzled out because it just added lots more complexity, made things much more complicated to use. That's where we were back in October. And what was discovered at rebooting Web of Trust, and I am happy to say I had some things to do with it, is we found out that they actually work really nicely together. And in fact, there isn't a lot of need for this controversy because actually you can use AnonCreds and W3C credential. So it turns out putting it into the credential is pretty easy. There's a link here to proof of concept with code and examples. And basically what that does is it takes an AnonCreds credential, converts it into a W3C verifiable credential data model, and converts it back if necessary and when necessary. And then likewise takes a presentation, an AnonCreds presentation, puts it into the W3C VP data model, and converts it back. And so what that means, you've got this two-way transformation. What that allows is you can issue a credential in the VC data model format. For processing it within AnonCreds, you simply swap the model back, process it, and do what you need with it. And when you want to, and that's all you need to do, basically. And the way we did this was simply by moving around JSON. We took the signature on the VC and VP, made it contain identical data in the AnonCreds presentation. Everything else about the AnonCreds credential, the canonicalization and presentation, the canonicalization, the signing, creating presentation, verifying, all stay the same. So there's no difference in the processing. All features of AnonCred are supported. So kind of cool. I'm going to quickly go over this and then pass over to Patrick, who's going to show some cool stuff he's done with this idea. But basically, the CredDef ID becomes the issuer ID. The schema becomes the schema. So it's referenced in the credential schema type. There's a type of AnonCreds. We've got the idea of the schema in here. And then our credential subject, our raw data goes into here. The encoded data does not go into here. Remember I mentioned that it would be better if the encoded data wasn't actually in the various AnonCreds objects shared. In this case, we don't put it in, we use the canonicalization approach. So that's I'm not encoding auto, meaning, oh, just generate it yourself. You don't need me to pass it to you. You can figure it out yourself. The signature, all of this data in here simply goes into one big long, and yes, it is a very long base 64 string, which can be converted out of base 64 and back into this. That's the back and forth. We have a JSON LD context, which defines everything like CL signature 2022 and things like that. And then we have a second component, and this is for those who need to know about JSON LD. This allows the definition of all of the fields within here generically, so that we get generically a way to specify in a JSON LD what these items are. And this could be replaced by an issuer-specific context. Again, this is JSON LD inside our info, so only if you understand JSON LD will you understand this. But we could introduce a new concept in AnonCreds that allows an issuer to specify an actual JSON LD remote context that would allow definition of the credential subject values in it. And that would make it fully aligned with the data integrity. This also allows us to use some sort of what's called crypto agility. So crypto agility can be done by adding multiple signatures to a credential so that you have both flexibility and long-term vulnerability protection. So the way that, and so the idea there is you would put a NIST approved, an ED 25519 and a quantum safe signature on the same credential. And so we've carried out proof of concepts with AnonCreds where basically down here, this can be basically a list of proofs. So you have the AnonCreds proof, but you could also have a data integrity proof, a traditional W3C proof. Both of them would be on this. If you use the data integrity proof, you would basically share with the verifier the entire credential. But if you use the CL signature, you would, the AnonCreds credential, you would have all the features of AnonCreds. So hopefully that makes sense. You've got a VC that can be presented using AnonCreds or not, and it enables by just generating the two proofs as you issue the credential. So with that introduction, I'm going to turn it over to Patrick St. Louis, who's from the Digital Identity Lab of Canada, who is doing some phenomenal work at crossing over the communities. Remember that communities that I showed you early on, that slide with the 4 different communities that are happening? This guy is doing a fantastic job at jumping across them and figuring out stuff that's happening across them and trying to find synergies between them, and doing a really great job. So with that, I will turn it over to you, Patrick.
All right, thank you. Thank you for the brief introduction, Stephen. Let me share my screen real quick. So this is the one here. So in my presentation today, it's going to cover many different topics. So I won't go into detail into much of them because we could be here for a long time. But it's going to cater directly to the last section that we saw, using AnonCreds in a W3C data model format. And also when we were talking about different methods, this is going to use the did-web method, which is a very convenient way to understand these topics, because it takes away the blockchain and the ledger side of things and focus on the different elements and the portability of AnonCreds. So a little overview of the technologies used in this presentation. So there's a few links here. I can share this presentation after, no problem. So this is sort of the way I see it, is a kind of mix and matching different specification. I did not directly create any of these. I participated in the did-web AnonCreds method with Ariel, which is another member of the community. Where I come from is at the lab, we sort of keep track of everything happening in different spaces. So by doing that, we participate in many different communities on a weekly basis, attend different calls, and see a bit what is happening. And from my side, I like to just take different solution and try to mix and match it, a bit like some form of alchemy, if you could think so. So yeah, I put a few links here of all the different protocols, standards, specification, whatever that are used here. They're mostly in the Hyperledger space and the W3C credentials community group space. So the first question is why would I bother using CHAPI and the VC API to issue AnonCreds? So the key here is interoperability. So interoperability is always at the core of a good ecosystem, especially with digital ID. And when you can demonstrate interoperability, which is a whole different thing, well, it attests how frameworks are built with a solid foundation, right? And they meet their goals. Because you don't want to pigeonhole your solution and lock it in a specific space, right? You want to be able to move around and create a great ecosystem. So this demonstration will show two things. We'll show how, by design, the WTC data model is very adaptive, and that was one of their core principles. And the second way is to attest of the modularity, portability, or the ledger-agnostic side of the new AnonCreds library. Before I start, I just want to put a special notice to this page here. So this is the contributors page for the AnonCreds Rust library. So as you will see, my name is not on there. I am not, I did not contribute anything there. I'm very much an enjoyer of the final product, but a lot of the, sorry, my webcam froze, but that's okay. A lot of the credit will go to most of these individuals and many other, you know, with open source, it always builds on precedents and always build on other code, but I just wanted to make that very clear here. So just 4 words, I want to just define, make sure we understand. So when we talk about issuing, the action of the issuing a credential is really the issuer embedding a cryptographic proof in a credential before it sends it to the holder. When we talk about deriving, it's the action where a holder will select claims from different credentials and join them together in a presentation in order to match a presentation request. The act of presenting is when the holder responds to a presentation request with this derived presentations. And then finally, the verification is when the verifier will validate the proofs from that derived presentation to make sure they're authentic and they have been issued by the issuer. This touch, in our case, mostly the credential definition. So what is CHAPI? So CHAPI is a W3C credential community group initiative. It's a credential handler API. So it's a browser API meant to interact between your browser and a browser wallet. So it will send, it will allow you to select a wallet and it will actually send the information to that wallet. So we will use CHAPI here to carry 2 action. We'll use it to store our credential and to present our presentations or a credential. And then the other component is the VC API, which is also an initiative from the WTC credential community group, which just is more meant to manage the life cycle of the credentials. So here we're talking about actions such as issuing, so embedding the proof, deriving presentation, and verifying the presentation. So depending on the action you're taking, these endpoints would live either on an issuer system, a holder, or a verifier. And in our case, of course, we'll use the AnonCreds Rust library to sign the objects at the end. So finally, the didWeb method. To demonstrate this, I'm going to use the uni resolver here to see how I publish my items and how I abstract the ledger. And finally, the magic behind all this is this back and forth mapping between AnonCreds object and the verifiable credential data model. So all this is thanks to this project here, which is the sort of proof of concept made by Andrew Whitehead, which is a sort of initial attempt at doing this back and forth mapping, and it's working quite well. So how it's going to work, we will have a credential in a JSON LD format with a credential request. We're going to send it to the API. Then we're going to map it to an AnonCreds object, process the objects, bake in the proof, map it back to a JSON LD, and then return it to the user. So that's how we're going to use the VC API for this. So let me go ahead. So this is a very small, simple application that I've made. I can post the link. I made this specifically for this workshop to demonstrate this. So I can link without a problem. So we're going to use this as our sort of UI to understand a bit what's going on. We have this API. It's another thing I've been working on. So it's a sort of a VC API implementation of the AnonCreds Rust library. So we have a few endpoints here. We have the issue, derive, verify, and I've also added some mapping capability so we can see easily see the JSON LD to AnonCreds object representation here. For the wallet component, I'm going to use this web wallet. It's called Veres. You can sign up for their demo. It's a browser wallet. You just need to go at demo.vereswallet.dev. It's going to ask you for your email. You make your account, and then you install the wallet. And finally, the universal resolver. So like I said, I use the didweb method. It's up to spec. So how I manage to publish my schema and my credential definition. So when you have this spec, you need to have what's called a did document. And according to the did core spec, you can define services. So for this proof of concept, I've defined a service for my schema and a service for my credential definition. So when someone gets this did, they can simply go fetch the did document, go access the service, find the ID of the service that corresponds with what they want to fetch as a resource. And each service is comprised of an ID, a type of service, and a service endpoint. So if I want if I have the schema ID, for example, I would simply go fetch the ID, go fetch the corresponding endpoint, and I have here my schema. Same thing for the credential definition ID. So as you can see, the credential definition ID, so I'm gonna, maybe my font is a bit small, sorry, I have a large screen. So you can see it's quite different. So since the credential definition contains some cryptographic material, what we have included in the spec, the didweb spec, is the ID is actually a checksum of the content of the credential definition. So when people go fetch, when the verifier goes to fetch this credential definition, they can actually verify that it's not been modified by compressing this. It's a simple formula, so it's a minified version of this information, and then you generate a SHA-256 of the information, and you base 58 encode it, and then you get this little hash here. So this can be also calculated as an extra step from the verifier. Obviously, when you use blockchain, you have this sort of data integrity built in as a feature of blockchain technology. But with didweb, you need to find other creative way to ensure these mechanisms that are taken for granted from a ledger. So this is how I'm going to manage my IDs for the different objects. So first part, we're going to issue and store a credential. So if we look here, this is the type of payload that we would send to the VC API. So we have firstly, we have our credential. Okay, so we want to issue a credential for the schema that I've just presented. So we have my 5 attributes: our email, organization, expiration, given name, family name. This is taken care of. It's an AnonCreds credential. It's properly defined. I have here my credential definition ID and my schema ID, the values that are inputted. And then here we have the component is the credential request that the holder sent. This is where the link secret has been leveraged to generate this presentation request. And what the VC API will do is it will take this credential request and bake it in this credential. So this is where we see this. This is what we're seeing here. So we're seeing the credential and the credential request. These are the 2 items that we see. So how it would work, I would take this payload and then go over to my VC API here. I would simply put this in, execute it, and there you go. I get an output, it baked in the proof. So now I have my credential that's been issued. But once it's been issued, after this, it needs to be stored in the wallet. So that's where CHAPI comes in. So as the second option, I can here, well, this is in the way. How do we move this? There we go. So as we can see here, so this interacts with my browser. So CHAPI is going to prompt me to select which wallet I want to store this in. I hope I'm sharing my screen properly. There's a pop-up that just appeared here. So I have a few wallets I can choose.
Wallet.
I'm sorry.
We can see choose a wallet on your screen.
You can see it. All right, perfect. Because sometimes you only share a window, and it created some problems.
Totally get it.
I'm glad you can see it. So there's a few wallets. These it works in all of these, but I find the Verus wallet is interesting option. So I will choose the Verus wallet, and then it's going to prompt me. It's going to say the DTT Playground wants to issue me an AnonCreds workshop pass, which is a conceptual credential, and it's a digital pass to access Playground features. So I'm going to go ahead and store this, and then once it's stored, I can go see if I refresh this page. I have a stored credential here, so it's stored. It doesn't show on this page the content of the credential, but it's the credential that we've issued here, as we see it's this section. And furthermore, we can then go see for the curious mind, we can simply paste that credential in here. Oop. Execute this. And then I have the AnonCreds representation of that credential. So this is this sort of back and forth between two models. So this is very interesting because the VC, it's not really a VC anymore. It more becomes like a medium to carry all the cryptographic information that I need to process whatever I need to process, whether it's to create a presentation or so on and so forth. Second part, I'm going to derive a presentation, and this is where we're going to showcase selective disclosure and zero knowledge proof. So as we can see, we have this credential. So this is the credential that I've stored in my wallet, and this is my presentation request. So we request some information. So as we can see here, we have 5 attributes. I'm going to choose to share my email in my organization only. So I'm not going to share my family name. I'm not going to share my name. I'm just going to share the email in the organization, which is what the system would hypothetically need to identify me, to send me into the right resource. And I'm also going to make sure that the credential is not expired. So I'm going to do a lower or equal on this date that I want to make sure it's not expired. So we're going to go again and again, just take this payload, and we will enter it in the derive endpoint. And then there we go. So this is very interesting here. We can see now in my credential subject, I no longer have 5 attributes. I have the 2 attributes I've requested, the organization and the email. And I also have a proof that shows that I matched this predicate, that the value that was in my credential subject and the expiration date is smaller or equal to this value that I want to check against. And all this can be verified thanks to the proof. And then once again, we can take this, we can map it. And we can see the presentation, what it looks like, and the AnonCreds format. So this is very back and forth recipe. It works every time. So then I'm going to go ahead and start this presentation. Okay, so there we go. We have this presentation that I want to store. So if you look here, I now have my credential and my presentation. So we can see here we have the pass, and then we have the presentation, which is derived from this pass, but with only the values that I want to share. And then finally, so we have this presentation that we have in the wallet. I'm going to be asked to present it. Okay, I'm going to choose my wallet. So it's requesting it's a credential request. So DTP would like some information, and automatically it knows to select my presentation. This is a query by example. It's a verifiable presentation. We can see in the spec, there's the VP request specification here that you can have a look. So it's a query by example. So I'm querying on the type, which is an AnonCreds presentation in this here. And then I can share my presentation. So I've not shown visual feedback of what's being shared, or I did print it in the console. So if you, for the more curious, here you can see the information that the website would have access to when I share this. So they would have access to this presentation, and then they can, they would have these sort of endpoints, so they could map it, or they could simply verify it. So if we want to verify, we can just take this presentation that I've just sent here, and then have this verified endpoint. Let me just close this really quick. Oh, I think I copied something by accident. I'm going to verify this. And it should returns me true value. So all this verification is done with the AnonCreds Rust library. I'm using the Python wrapper, so it's a very Python implementation. This is a fast API server, and this is a Flask web server for the developers among us. And we can see if I just change any of these values, if I want to pretend that I'm some other user, for example, and I check it, and now it's been falsely, it's not true anymore. So it's kind of working, And I'm not a cryptographer, so I very much trust the work that's been done. This is a good way to test also what has been done. So this is the main part of my presentation. So we went over the didweb method for AnonCreds, how we can share this information with a browser wallet, which is an interesting alternative. And we went over a bit the VC API, what it could be done. I have other means to create schemas and credential definition, but I've kept this out of this presentation for time. But you would simply make these schemas, you would create them, store them. I use a Redis database for this, and expose them to my API. And then according to the the didweb spec, you just simply need to go resolve your well-known did.json document. And then you would add services depending on your different schema or credential definitions. This is one way to do it. This is the way that I've chosen to respect both the didweb and the didcore specification, and seems to work very well. That will be it for my presentation. Sorry, I lost the meeting.
You lost the meeting. Whoa.
Yeah, I lost the Zoom window.
Too many windows open.
We're here somewhere.
All right, perfect.
That's awesome.
So this was both validated with some member of the Hyperledger community and the VC API people. I presented that just last night, and they thought it was really, really interesting. So yeah, this is a nice sort of cross ecosystem proof of concept that can drive many interesting conversations.
Awesome.
Thank you.
Okay, thank you. And so we'll wrap up. There's a few more, a couple more topics that I want to touch on. Won't take long. We won't go past 11:30 Pacific time. We won't go past the half hour, but I did want to hit on two more topics just to cover this. These won't take long. AnonCreds and what is called Overlays Capture Architecture, or OCA. This is the Making Credentials Beautiful section. And as we've evolved AnonCreds and the use of AnonCreds and Aries and using these different capabilities, more and more we're getting these out into the real world. The BC wallet has been published. The Orbit is out there. Different wallets are out there, and user experience becomes a huge issue. We're dealing with people that we really want to demonstrate this to, that need to see this is a credential. This isn't just a bit of JSON that we're dealing with. The problem we had was that there's minimal verifiable credential metadata about it. AnonCreds provides very little data. I tried to show this early on. there's an issuer did, but no standardized way to get more information about the issuer, like their name or description. There's an alias on the DIDCOM connection between the holder and the issuer, but there's no way to know who that is. The schema object contains a list of attributes. You saw me go through and see that given underscore name, family underscore name, birth, date of birth underscore date int. Those are the things we put in the schema. Credential definition doesn't have anything remotely, anything useful from it for helping to display it. And then things like issuer branding, being able to have the colors match, have an image that reflects the brand of the issuer. None of that is available. So that's what we were trying to overcome as we thought about that. One thing I didn't even mention there was multilingual. How can we present beautiful multilingual credentials with so little data? We just don't have anything we can use. We then began to look at overlay capture specification. Another slide that's slightly out of whack. I'll get that fixed. So overlay capture architecture is something that started in the pharmaceutical area and was now under the caretaker, the care of the Human Colossus Foundation. So the idea here is you have a data structure. It can be anything, but for our purpose, the base, the capture base, that data structure is the attributes in a credential plus the list of attributes within it. So that's our base. And then what you have are overlays that link back to the base and that allow you to specify different components that overlay on top of that base. So for example, you can have a label overlay that goes on top of the capture base, a list of attributes in that data structure, and contain all the labels for the attributes within it. And that label can be language specific. So now suddenly I've gone from having just a list of attributes given underscore name to an overlay with specific labels and one label overlay per language. I can add character encodings, data format, the standards that are applied in using that data. I can have units of measure. This is millimeters. This is maps to what does the data mean. Metadata, the meta overlay, again, is language specific, but it talks not about the individual attributes, but the overall data structure, the credential itself. So the name of the credential, the issuer of the credential, and so on. So all of these overlays are available in a standard way that apply to the base, which is our schema. So that's what we do with overlays capture. It's data set based, not attribute based, which is more along the lines of what JSON LD is. Each overlay is JSON. There's an array of overlays. The overlays may even be in separate files. There is a tie to the specific capture base, the underlying data structure to which it applies. Some overlays have a country language code, so that's the multilingual language. And then most overlays, there's an element per attribute. So here's an example. This is the reference back to the capture base. It's a label overlay. Its language is French, and for the attribute labels, which are the items in the capture base, here is the French language labels to use for each of those. So imagine that expanding out, that we could have all of our languages supported. That's what OCA brings us and why it actually turned out to be really useful. So here's what that credential I showed you looked like earlier. I have an issue date that looks pretty good, but only because the wallet put that in, and it knew what moment in time it was issued to it, so it gathered that information. But this is the issuer, this is the credential, there's our schema name and schema version. We've got our underscores in our names. We've got the expiration date in that format that I said. We've got expiry underscore date, kind of ugly. Here, we've got a logo for the issuer. We've got the name of it. We've got a background image on it. We've got all of the names laid out. We've got the date formatted in a way friendly to the type of person that is looking at it. In other words, it's respecting their settings in their app. And here we can convert it into, have it presented to a person that is a French speaker and using it. All of the items are updated. The logo stays the same. There's only one logo, but the labels are all fixed. The items in the wallet themselves are multilingual. So that's the idea of what OCA does. Pretty much everything you see here outside of this issued and these hide alls, which are wallet specific. Everything else you see that's different across these is because OCA has been applied. We've been looking at a number of ways to deliver the OCA bundle. So an OCA bundle basically says, here is a bundle associated with a given credential from an issuer. When you get the credential, go get the bundle, and then you can use it to display the credential in a beautiful way. We decided to go with the use of a GitHub repository for the bundle. And we've got an initial cut linked in here of what that looks like. The GitHub repo contains some governance around it. Much like those who are familiar with open source software, you've got a set of maintainers. The maintainers have rules to make sure that the validity of the data is accurate and useful, but the content is up to whoever the issuer is. So anyone can submit an OCA bundle into this repo. We will accept it if we verify that it is actually an OCA bundle, that you represent the issuer, that the bundle has a schema that is published somewhere and you've identified. So there's a set of data integrity rules around that are currently manually defined, but once that's accepted, the bundle gets published into this repository and a wallet can pull it from the repository. The wallets are being built to know about this repository, and when they get a credential, they look up in their list to find out if the OCA bundle is available in this repository and pull it in. So that's our short-term way of doing that. We've got, oh, excuse me, a little demo or a little explorer to show. So if you log in the first time, you get some help as to what OCA Explorer is, some links to the various background information, how to select a bundle, and so on. Any bundles that are in the repository are available. And so I can click on them and see what they're going to look like inside a wallet. I can switch between the languages. If I want, I can play with things like the colors on it to see if I want to change how it's presented. And as I adjust, I can see that. So as I change these settings, I can also download the branding overlay, this information that's in this overlay that allows me to brand it to my specific needs. So that's the idea behind OCA. You can also use this tool to upload your own that you've built. There's a whole bunch of documentation around how you build OCA bundles. A lot of it is managed actually through an Excel spreadsheet where you have a list of your attributes, and then you've got a place, basically a tab for each language that you're going to use. And then that Excel spreadsheet gets converted into an OCA bundle. So just wanted to show that quick piece and show that that is there. And the last topic is AnonCreds v2. What's coming? Oh, excuse me. Sorry about that. AnonCreds 2. AnonCreds 2 is began with a working group that started in early 2023 defining AnonCreds next. The goal is AnonCreds is not particularly tied to the CL signature or the particular signature being used, but rather is about the set of features, the privacy preserving features that are in AnonCreds. And so the goal of V2 is to retain and extend the features of AnonCreds 1 while improving capabilities, performance, extensibility, and security. So that's the goal of AnonCreds 2. Here's highlights a few of the things that are being offered or being suggested in 2.0 and that we're working on as to how to do this. Basically, all of these capabilities, we know how to do it. We're just trying to nail down what will go in the spec. How do we balance the new capabilities with with a reasonable adjustment to the interfaces that are used for AnonCreds? How do we make this easy for evolving from AnonCreds 1 to 2? For those knowledgeable of underlying cryptographic signatures, most likely BBS Plus or PS signatures will be used. As I've mentioned, scalable revocation is a key. We've got a number of candidate approaches to that. If anyone is interested in revocation, if anyone has a cryptographic background that would like to contribute to that, we've got some really good things happening there. We want to use the W3C data model standard as just a given that we'll use that. I expected that diff presentation exchange would be used. There's now another option being proposed, but we assume instead of the current AnonCreds request presentation, we would use the diff presentation exchange. And then relatively small changes in the data objects and data models. Basically, same objects would be there, different data, possibly one other object, same relationship. So that's the idea. The cool thing here is exposing more predicate-like capabilities to give you more flexibility. This is a big one, the ZKP attribute equality. Prove that two attributes in two different credentials have the same value without exposing them. So something like proving that your name is the same in two credentials without exposing what your name is. Even more verification that the credentials belong together without sharing further information. Timelines, not too much available. It really depends on how engaged the community gets in doing this. We've made a bunch of progress, but we really have to get the community engaged in building components of this. That wraps up. We're a minute over, so I'll just say what to do next. These were our goals coming in. Our takeaways are hopefully you know how to use AnonCreds in your application. You can build frameworks that embed them, and you can contribute to the community around, and you know how to do that. A pile of links here of things you can use. We will be sharing links to these links and links to the slides in a follow-up email. Building frameworks that embed it, work with the Aries community and using AnonCreds, build it into your own proprietary framework, but do it in a way that interacts with others. We'd love that. Add support for AnonCreds beside other credential formats. Use AnonCreds, for example, in an OpenID for VC exchange. That could be very interesting. Got a pile of things that we've talked about already. The one I wanted to highlight here is NimLab and what they're doing. They actually have an AnonCreds verifier built into a smart contract, an on-chain smart contract on the Juno network. What that allows is for doing DeFi, decentralized finance things that by executing a on-chain smart contract, a off-chain verifiable credential can get verified, a presentation provided and verified, and then the transaction can continue. So information is collected and verified as part of an on-chain smart contract. But you're using verifiable credentials. Super interesting. A link to NIM Lab is there. Recommend people interested in a blockchain merging of verifiable credentials take a look at that. If you want to contribute to AnonCreds, a bunch of links here of the meeting calendar, where the specs are, and when the meetings are. The next AnonCreds, again, meetings, the spec is there, early days, but we're really looking for moving forward very quickly with AnonCreds in W3C format and scalable revocation. If you have any interest in that, please join us. And that's it. 3 minutes over. Thank you all for coming. Happy to answer any other questions. And follow up with us in on the community in Discord and so on. And thank you so much, Rodolfo and Patrick and Sean, for helping out on this. You guys did amazing. Thank you.
No worries. Thank you, Stephen, Patrick, and Rodolfo for putting on such a great workshop. In the chat, I have included some links to places like the AnonCreds wiki page, the wiki page for this workshop, which is going to include all the slide decks and the labs documents, as well as the video once it's done encoding, thanks to YouTube. As Stephen said, this is an open source community. Anyone can work with this code. Anyone can use it in their projects. We would love it if you participated. We would love it if you became a contributor and moved into the maintainer status. That would be awesome. But we are powered by our community. This software doesn't write itself. It's the awesome people like the three presenters here today who make AnonCreds happen. And we hope this was valuable. You got a lot out of it. The video will be on the Hyperledger YouTube, so you can refer back to it. And thank you, everyone. We really appreciate everyone taking the time today for 3.5 hours of awesome workshop content. If there are no other questions, I'm going to end it.
Go for it.
Awesome. Thanks, everybody. Have a good one.